Okay, attempt number 2 to get quality options. And yes, Phoenix it is today. Hey there, Nui. All right. I'm going to do day 3 of learning Rust. And I just noticed that my current task is out of date. So I got to fix that. We're going to... Why does it say guessing game for Rust? Oh, because this is the parent directory. Okay. Oh, we're in the correct directory already. Okay, great. Current tasks. All right, so this is day 3 of me learning Rust. And my chair wasn't set up right for some reason. Let me adjust my workstation here. Okay. We're on chapter 9 now, aren't we? I kind of breezed through chapter 8 without even saying that we were on chapter 8. We're on chapter 9, error handling today. Error handling. All right. So, if you missed the last 2 of my streams, or it's the first time you've been here or seen this on YouTube or wherever, I am learning Rust from the Rust book. And I have already gone through chapters 1 through 8, and I have the basic groundwork on how to start a Rust project, either a library or a program, and do basic stuff. And I know about collections and matches and all sorts of stuff like that. And now I'm moving on into, today we're going to be handling, I think, error handling, lifetimes, testing, closures, iterators, and maybe if I get to it, more stuff about packaging and smart pointers. Hey there, Resubaka. Start my timer because I forgot. All right. All the things that I like to have are set up now, I think. Yeah, who do you watch now, Buff Seagull? Maybe watch both at the same time? Both Go and Rust simultaneously? Double language download. Hey there, C17R. Greetings, program. Hey, if only Adam was learning Rust at the same time, then it could be like a double Rust experience. All right, let's jump right into it. I'm going to learn about Rust error handling. I did a sneak peek, and the one thing that really got me excited was where? Let me try to find it again. Rust doesn't have exceptions. Woohoo! Good morning, Acton Def. Can you tell how much I dislike exceptions? Don't have enough screens, yeah. So I'm really excited by this statement. Rust doesn't have exceptions. So basically, Rust uses the kind of error handling that I'm already used to doing, which is that you return it if you care about it. You're more interested in Rust than in Go? Well, there's always VODs. So you could learn both. Just put it in the correct order for you. Learn one first and then the other. Okay, Rust groups errors into 2 categories, recoverable and unrecoverable. Unrecoverable sounds really scary. Recoverable errors like file not found. It's reasonable to report the problem to the user and retry. Unrecoverable are always symptoms of bugs trying to access a location beyond the end of an array. Yeah, so traditional crashes, panics. Hey there, Romania hate. Most languages don't distinguish between these 2 errors. Well, I don't know about distinguish. Most languages I know of do distinguish between those 2 kinds of errors in the form of what type of exception is thrown. But Rust doesn't have exceptions, so. Breaking news, when asked about their unreadable code, the programmer declined to comment. Good one. Good one. Seg faults. That is a kind of exception, Shiva12. Hello. It's a hardware level trap or exception. I think I know what they're trying to get at, though. They're basically saying that there's the same mechanism is used. When they say distinguish, they just mean distinguish through different mechanisms. Some signals in POSIX are to flag exceptional conditions, but others are not, right? think it's saying in C++ you might get an exception if there's no real way to recover in the end. It's the same type. Yeah, I was thinking like structured exceptions or the way Windows handles access violation and other kinds of things. They're all exceptions. They're just... But okay, yeah. Let's not mince words, right? Rust has a result enum for recoverable errors and the panic macro for unrecoverable errors. And we already know about panics because we can cause them easily by hitting Control-C, right? Or just parsing a string to make it an integer, and it's not an integer. All right. Sometimes bad things happen in your code. There's nothing you can do about it. In these cases, Rust has the panic macro. I hope I never have to call that. Print a failure message, unwind, and clean up the stack, and then quit. So one reason I never want to call that is when they say things like print a failure message. My first question that I jump to is print it how and where. I guess that's two questions. Because, for example, let's say we're writing an embedded web server in Rust. We can't print. And we could maybe put it in a log file somewhere, but how do we know it's going to go there with panic? Maybe there's a way to set it up. That would be nice. It's unwinding the stack and cleaning up data, walking back out. The alternative is immediate abort, which I'm familiar with, yes. Hey there, mdtrodev. Yeah, today is day 3 of me learning Rust. Hey there, Epic Unknown. Oh, you changed your handle. Okay. Metrodev. And AU96 Rust. Yes, I'm learning Rust. I'm a C++ developer that is learning Rust for the first time. Hopefully the only time, because it would be sad if I would have to relearn it. You have me on your laptop. You got Adam on the iPad. Okay, there you go. You got the full setup, Buff Siegel. Great. I'll try to speak when Adam is typing and not... No, just kidding. Wouldn't that be eerie if, like, you had two streams that are synchronized in such a way that only one person was talking at once while the other one was typing? Learn, then forget, then learn again, achieve mastery? Maybe. But if I have to do that, maybe I'll at least have my notes. Hey there, Nightshade Dude. And Trumpsis, hello. You started learning Rust for game dev. Great. Do you know about this site Chris Griffin gave me? It's Are We Game Yet? This one I've been told is a great resource for if you want to use Rust for gaming, because it has a whole bunch of collections of resources and the state of Rust as far as how people are using it for game dev. And also if you're hoping to use Rust for web dev, there's this link, Are We Web Yet? And this one is, like you might imagine, state of the Rust environment as far as using it for web dev. You find the tutorials given there. Great. All right. Those for me are more advanced because I'm still reading the book. All right. So again, I'm on chapter 9. We're reading about error handling. Is there a public link for my OneNote? Yep. Notes. Oh, that reminds me, I got to update my today command. I forgot to do that. Look, I have no linky link. Okay. Sorry, I got to take a little side note thing here. I'm following my own link there, the notebook page. Basically, to go to the log. Wait for it. Okay, and then down to today's stream. And then I gotta wait for it. And then I gotta right click, make a copy to that page. And then I'm gonna go to tiny URL. I'm gonna paste the link there, make it tiny, copy to clipboard. Paste it back here to verify it works, and then I'm going to put it into my bots today command and my notebook. It's a self-referential notebook. Can I just paste it from there? Nice. Okay. Go to my game. I'm going to update my games. Just going to my game because my game also doubles as my chat bot. I'm not going to be playing or working on my game today, but I'm going to use my game's admin panel to update my today command. Learning Rust. He started on chapter 9 of the book today. Check out today's plan here. Update. All right. Goodbye, game. No problem, Duck Engineering. And hello, by the way. Oh, it's Duck Engineerding. I like that name. How are you doing? And A squared, how are you today? Rust. Exactly, we're rusting here. You know, I've been, I'm sort of like what were we saying? I'm sort of like a Twitch dad. I'm a dad in real life, and I'm sort of older than the average Twitch viewer. And so, like, when people ask me how I'm doing, these days I say, I'm so old I'm rusting. How did I do that? You mean the games, the game, that what I usually do here on Twitch is I'm working on my own game. And you can read about it more at that link in my notebook. Or you can actually just try it out. It's still a work in progress. But the game includes Twitch integrations. So on one of my game's control panels, I have like a list of all the commands that my game will respond to in Twitch. So when you see Omni Arena, that's the actual game that is connecting to Twitch and reading chat. And whenever a command that it knows about is spoken, then we, yeah, exactly, then it responds. Just like a typical Twitch chat bot. And that was done through about a year and a half of work. All right. All right, so where was I? All right, so we can either do unwinding or we can immediately abort. You can switch to unwinding to aborting upon panic by adding panic equals abort to the appropriate profile sections of your cargo toml file. Okay, so it's sort of an option for the compiler, so to speak, right? Let's try panic in a sample program. Panic, crash and burn. All right, let's do it. I feel like trying it out. I can do this with a terminal window, right? Cargo, new panic. And then I can go to panic and then paste the code there. Crash and burn. And now I'm oh, sometimes I have to reload this window to get my run button to work. Yeah, the Rust plugin is acting sort of funny some days. And now, okay, that's working, but I don't get my run. Oh, wait. I know why. Okay, never mind. Forget I was talking about run button. That was another plugin I was playing with. Panic, cargo run. That's how we're going to run this. There we go. Thread main panicked at crash and burn. Line 2, column 5. I've been streaming for 12 minutes, 9 seconds. Actually, I've been told that now it's built into the Twitch viewer on desktop that you can see the uptime. So in addition to that, I have my traditional uptime counter. I'm wondering how close I got to the Twitch UI. Displays the same, yeah. Might be redundant, yeah. But you know what I found out is on mobile, there is no uptime counter, at least on my iPhone. I updated on my iPhone to the latest Twitch app just to check, and I didn't see any uptime counter there. On 30 seconds in advance. I had to stop the stream and restart because I didn't get transcoding options right away. I had to switch from LA to Phoenix for my uplink to get the transcoding options. So technically I have been streaming 40 seconds, 30 seconds longer. It's just I had to take the stream down for about 30 seconds to switch the uplink. Hey there, Red Rampage Crumpet. I'm glad you could make it here for another Rusty Programming Learning Day. Grumpy Game Dev, how are you today? And Dries Jans, all the people that I've normally liked to see are here. And it's a dub. It's a Thursday stream, yes. It's indeed a Thursday stream. And hello, Dragoneer. Everyone's piling in now. There were layoffs again? I'm sorry. Not you, but so not as grumpy? Oh, okay. Yeah, I'm sorry to hear that. That's affecting a lot of people out there. Hey there, Cloudhawk. And Mars Raptor. All right. Hey, thank you for the follows, too. So, we're following along in the Raft book. And I'm in chapter 9. We're seeing how do we crash programs, because this is very useful to know. Just kidding. It's just going through how Rust handles errors. And this kind of error where you can't recover is called panic, and there is teaching us how to actually do it to trigger ourselves. We've also seen in the past panics happen if you run certain methods that have that can fail, and then you can turn those failures into panics through other methods. Are you going to build with Rust again? I don't know, Dry's Chance. If in a perfect world, if I completely love Rust, I would just use that instead of C++. So that would end up being at least the back end to any kind of stuff that I work on, and maybe even front end stuff, because I heard you can build it in with WebAssembly to have it run in the front end. I don't know about rewrite the game, but any new stuff could be written in Rust. Why not? Build a game engine? Yeah, like haven't already done that. Yeah, WebAssembly. I've heard that it's not too bad. You just run cargo and WebAssembly and you're done. All right. Call to panic causes the error message to contain the last 2 lines. Wait a minute. Why is it? Oh, it causes the error. It's not technically an error message, though, right? It's a message you gave to panic. Anyway. Panic backtrace. Let's take a look at another example. See what it's like when panic comes from a library because of a bug in our code instead of from our code calling the macro directly. So yeah, let's do it. So here we're going to cause an out of range array index or vector index. So now I'm just going to run the same thing. I have to hit save first, right? And then run the same thing. And we have that it panicked at index out of bounds. The length is 3, but the index is 99. That's really nice that it gives you all that information. Don't you agree? A lot better than C++. I hope it's ABI compatible with C. If it's not, then I'm going to be very sad. But I've been told that it can interop with C, C++, so. Okay, good. If NUI says that's how they got it, then great. I was very sad when I was learning Swift to learn that I could not figure out how to get Swift to call C in C++ or vice versa. And I had to just abandon it and go back to Objective-C when I was on the Mac. I didn't like that. I'm like, Swift looks really cool. Too bad I can't really use it with my other stuff. Okay, Rust will panic using an index is supposed to return an element, but if we pass an invalid index, there's no element that Rust could return here that would be correct. There's interop. Okay. Swift is bad. I liked Swift, except for it looked like they were basically in a bubble. You couldn't interop with things easily. I hesitate to say it's impossible, because all I know for sure is I couldn't figure it out, and this was years ago, so maybe it's better, maybe I just didn't know how to do it. In C, attempting to read beyond the end of the data structure is undefined behavior. It's very bad undefined behavior. That's how how a lot of hacks get done, right? Buffer overflow exploits. Apple being in a bubble? Never. To protect your program from this vulnerability, if you try to read it, it'll stop. Yes, we know this. We can set the Rust backtrace environment variable to get a backtrace of exactly what happened to cause the error. Did they tell me that here? Oh yeah, look at that. So they want me to do exactly that. That's what I thought they were going to say. Rust backtrace equals 1. Can you do this in Windows? I don't remember if this works in Windows. Yeah, it does. With Windows, it's what? It's just set, right? And then cargo run. Yeah, there we go. So I figured it out. They were giving me Linux instructions or something. Look at that nice backtrace I got. Need to do that in PowerShell. Yeah, I'm using I'm old school. I'm using the stupid shell on Windows, CMD. Is Rust getting more popular nowadays, or is it just you? For me, Dry's Chance, it was occasional encouragement by my viewers to say, "Hey, you should check out Rust. Hey, Rust is pretty cool. Have you taken a look at it? Have you looked at Rust yet?" It got more and more insistent as time went on. So I figured, I don't know Rust, so I should at least look and see what it is. Looked at it, I liked what I saw, looked into it more, liked it, what I saw even more, then decided I'm just going to stream learning it. It's now the most wanted or loved language by some metric or another. So far, I really like pretty much everything about Rust. Let me share with you guys what are my not so favorite features. I actually gave this list to Musean, who is another streamer here on Twitch who does Rust all the time. And he actually responded to all three of my, not things I dislike, but things I don't particularly like. So to summarize what he said in my own words, the integer sizes are only fixed bit widths because Rust has to pick something at the LLVM layer. There has to be some binding to dictate how registers are assigned, and so it just happens to be I32 on my system because those are the defaults and the most optimal way to use integers in general on my platform. And there's an interesting side note: even though I'm using a 64-bit platform, 32-bit is more efficient than 64 because, roughly quoting what Museum told me, with 32 bits, there are more places for the optimizer to put values. So you can more efficiently optimize the register space when you're building the program. Whereas with 64 bits, there are fewer places you can put 64-bit objects in your register space. And it's kind of a waste if your numbers aren't at least 2 to the 32, right? Because that means all upper 32 bits are 0. Yeah, so what A squared is saying, the I size maps anyway to whatever, depending on the system. In what projects is Rust mostly used? I don't know. But there's the links that Chris gave me, which suggest that people at least want to use it for web dev. So here's the web dev, if you want to read about that, and game dev. And if people are trying to use Rust for web dev and game dev, that's a pretty broad application, right? So I imagine if it's a systems language also being used for web dev and game dev, that's a pretty broad spread. There you go, A squared's using it for web dev. There you go, Ecton Dev is using it for web and game dev. So I think that means you could probably use it for almost everything. Discord replaced Golang with Rust for some of the data structures. Interesting. Yeah, so far I like how Rust handles data structures. It's really nice. Okay. So the details of the backtrace are not so interesting. It's really handy that we can see the backtrace at all. I'm not going to look at the detail. I'm just going to run with that and know that we can see that. Debug symbols are enabled by default for debug. Okay. You have to have debug symbols. That makes sense. So line 17 points to our line. Let's see if I can see the same thing in my program here. It was on the terminal, yeah. Let's see if I can see it. Right here, right? Oh no. A little bit further back. Hey there, Doggo Doggo. You stumbled upon it by accident. Yeah, that's exactly right. How are you doing? And Silenzy, hello. And the Elephant Seal, hello. You guys must have enjoyed the stream so much yesterday. You're coming back today. I'm very honored. I'll try to educate and entertain as best as I can. Okay, I don't actually see the line that they want me to see. Line 4. I don't actually... Oh, this one? For me, it's the 16th line. Right, and then what my code is doing is calling vector index, and that's a clue. Although the error message they told us is pretty comprehensive. Index out of bounds, the length is 3, the index is 99. Because that's exactly what we did wrong, right? So vector of 3, we index 99, out of bounds. Enough said. We'll come back to panic when we should and should not use panic to handle error conditions in the to panic or not to panic section later. Next we'll look at how to recover from an error using result. Alright, here we go. So we kind of already did this, so I know where this is going. Yeah, I mean, they already introduced enum, so we know how to do that, right? So if you want to be able to interpret and respond to an error, then you'll be dealing with the result enum. Either has OK or error. and it's a generic, so the T could be anything, including, I guess, an empty tuple. And then E is the message. They call it a type of the error, but I'm guessing it's in general, it's a message, right? Okay, so they want me to do this to see what it looks like. Let's do it. Paste that, save, and cargo run. Okay. Undeclared type of file because I didn't use, so I don't really like to do that specifically. I'm a fan of naming things directly, but that's just my own personal opinion. Don't take that as dogma. And we're going to run this. Okay, it doesn't panic. I think that's what they want us to see. It didn't panic, but we also don't know that it failed. We could, how do we know that it returns a result? We could look at the API, or we could ask the compiler. If we give F a type annotation that we know is not the return type, that's sort of a roundabout way. How about we just put our mouse over the F and we see that it returns a result? Standard result. I'm surprised that they don't just say that. Like, yeah, sure, if we didn't have IntelliSense language server, we could do that like they said, and then the compiler error would tell us the same thing, right? That's interesting. There we go. Mismatched types. Expected U32 found enum result. Sure. But I could just hover my mouse over it and it'll tell me the type. Look at that. Teaching you how to do it without tools. Yeah, but I don't forge my own metal with my hands. No, just kidding. Yeah. Sure, I guess it's valuable to know how to start a fire with flint and tinder, but we don't typically do that these days. But yeah, we're gonna end up using the tool anyway. In order to compile, we're using a tool. But I know I'm being difficult. But yeah, you're right. They want us to run cargo check or run and see the error that way to see what the type is, because they say what it is there. That is correct. But you know, however you do it, it's nice to know all the different ways you could do it, though. So you could look at the API docs, you could ask the compiler, you could ask your language server. Start my day by punching wood. Yeah, exactly. And then I have a completely automated universe by the end of the day. That is a Minecraft joke. Forge with bare hands. Yeah, actually I do forge my own tools sometimes, don't I? This is a stream about doing things from scratch. And hello, Suleiman Funny. You heard XI editors using Rust. They wanted to be the Fuchsia code editor, something like that. Oh, okay. Sometimes the tools get confused when you're in the middle trying to do big refactoring, and that little trick helps you figure things out quickly. Oh, just like compile. Yeah, the compiler is usually the most correct. Isn't that true? Right? Only 99% of the time is the language server correct, but compiler is correct 100% of the time. To make a pie from scratch, you first have to create the universe. Yep, and then you got to spin out the protons and electrons just right to get the sugar and the fruit. Yeah, well, the compiler's always right unless there's a bug in the compiler, and then you got worse problems to deal with. All right. So we're beyond this now. It might succeed and return a final handle. It also might fail. It needs to have a way to tell us whether it succeeded or failed, and give us the information if it succeeded. That's what the return enum does. So in case it succeeds, the value in F will be an instance of OK that has a file handle. In the case of a failure, it'll be an instance of error that contains more information about the kind of error that happened. So they want us to use a match. Let's see if I can do it without looking at the code too much. So that would be like match standard file open OK. Okay, I'm giving up already. How far did I get? I was wondering, like, what do I put for that name, but I guess it doesn't matter. So I could say, like, foobar, and it still works. I had a mentor who liked to do that, to challenge the significance of words and their meanings. So when we would get, like, into a debate about the correct word to use in a context, sometimes he'd get frustrated and say, I'm just going to call it a fibbledegidget. And I'm gonna need you to call it a fiddly-gidget for the rest of our conversation today, just to drive home how names are sometimes arbitrary and they don't really matter, and it's the context that matters. So I can call it foobar and it's perfectly fine, right? Error. And I'm going to call this message because that's what it really is, right? And they actually want me to do a panic. Fine. And this looks like it takes a formatted thing, right? This file doesn't seem to like me. Oh, and then we're using this style to do the pretty printing, right? Comma, that. And it's a statement, so we end that. Correct. So when I run this, oh, we get the nice backtrace too. This file doesn't seem to like me. Oh, we get a whole bunch of interesting information there. System cannot find the file specified. It's an OS error, code 2. Code 2? Actually, it's a standard IO error, you think. Yep. You definitely had times where you were sure the compiler was wrong and it was you. I think in my career, like spanning back 25 years, I've only run into a legitimate compiler error like twice. Once I remember it was a bug in a Microsoft compiler. It actually had invalid code gen. And the way I could tell that it was a problem with the compiler is the compiler actually told me there was a problem. When I ran the compiled program, it told me invalid instruction. So it actually emitted a machine language instruction that my CPU couldn't handle. And I traced it down to, oh yeah, they had a bug in their code gen. The only other time I can remember I found an actual bug in the compiler, it was like a long time ago, and it was an embedded compiler. And I think we just worked around it by doing it a different way, because it was one of those, you know, how in sometimes strange embedded environments, you get these compilers that are proprietary by Intel or whoever, and like they're 3 years old and they haven't had an update, and they're like scary and unstable. And we run into a problem, we'll just try it a different way. Oh, result has an error type of standard IO. So they're saying basically the type of this, it's not really message. I guess I should correct myself. This is maybe if we wanted to imply the type in our naming, we would say IO error, right? But standard IO result isn't in the prelude. How is this working? Maybe it is in the prelude. I don't know. Maybe they'll explain why. I'm not defining any variables of that. Yeah, but I've had to do usings for other trait methods. So I wouldn't put it past it to require a using. But in this case, obviously, we didn't have to have one because it works without it. Yeah, I don't really like it either when it's not clear whether or not you need to do a using or use or not. Only for RNG. Yeah, that was true. That was the only thing I've had to pull in. Hey there, 715209. We're doing day 3 of Rust. You haven't missed much. We're on Chapter 9, Error Handling. Also should wave to guy named Guy, who I didn't wave it to, who chatted a little bit ago. I'm matching on an enum. Expect to have the enum used. Oh yeah, we're using it here. Yes. Okay. I should probably hide this because you can't see the end of that line there. Okay, matching on different errors. Here we go. What we need to do instead is to take different actions based on different reasons. So it might fail because the file doesn't exist. It might fail for some other reason, like we don't have permission for the file. So we can do that by expanding our match by matching on the kind of, okay. So yeah, this IO error has a kind, so we can then match on IO error dot kind. And what are the kinds of errors we have? Error kind. So here we do have to use the using, right? Or I can be explicit, can't I? Standard IO error kind. What do they want me to do? Not found. And for not found, they want me to create it. Okay. It's nested matches. Create hello.txt, which has to have its own OK. A fibble digit. I'm just illustrating the absurdity of arbitrary names, right? They use FC. I'm using fibble digit. And then if it's an error, this would be, again, IO error, right? We're going to panic. We can't create, unable to create file. IO error. And then we need to have the other match, right? So that's other error. Okay. So we can put anything we want there? Okay. How about something else that Bob knows about? Because I'm just being silly. And they want just me to panic that. And they are illustrating that I can put it inside a block to indent, which I think is cool. So panic. Yeah, unable to open file. Something else Bob knows about. Stay hydrated. Thank you, the Epic Unknown. I don't have my redemption queue open. I'll have to open that in a second. Yeah, I gotta stay hydrated, definitely. Also, it's been really dry where I am, so my throat is sort of needs more water, I think. Okay, rewards queue. There is one reward in that queue, and it is from the Epic Unknown, and now it is complete. Grumpy Game Dev, cheers to you as well. Why am I should put the coaster right here so I don't have to reach over and get it. There we go. All right, what did I miss? Just labels the value, yeah. Used unknown message in WebSocket code yesterday for when you get a message you're not expecting. Drink the cat. We're not drinking cats. Although, cheers 715209. The cat actually might be on this tower. Let me check. Nope. I think he was there earlier and he must have jumped down. If my cat is on camera, he would be right there next to my face. But he is lurking somewhere else. Okay, so we're gonna run this, right? And it... Oh, did I not save? I didn't save. Let me turn off the stack trace because it's bothering me. Okay, I have a syntax error in here. All right, I didn't finish. That's my bad. You just end it like that, right? Missing something. What am I missing? Oh, right. I used this again. Okay, it ran. And it created the file. So, they probably are going to have me try setting the permission so it can't be opened, but I don't remember if I can know how to do that with Windows. Or maybe they're just going to say that's what would happen. The variant we want is not found, which we used. So it actually created the file. Because create could also fail, we need an inner match, yes. That's a lot of match. It's very useful, but also very much a primitive. So you can have a closure. In chapter 13, we'll learn about closures. Right-click, read-only check. Oh yeah, I guess so. But I have to put it into Windows Explorer, right? So right-click. It's not as easy as saying read-only, right? Be properties, security, and then oh, it's not that easy. If only there was a right-click read-only. Or are we talking about inside of Visual Studio Code? Yeah, maybe there's something more convenient here I could use. That would be under target debug. Right? No. At this level. Right-click. I don't see a read-only, though. But if I open the file, will there be a command to make it read-only? Yeah, they are a mess in Windows. Under general is read-only. Okay, so I do need to show that in File Explorer. Properties, general. Oh yeah, thank you. Thank you. Romania hate. Apply. So now it should panic with that different error, right? No, it didn't. Oh, because we didn't open it for writing, I think, right? It's actually able to open it, but if I think there's a... Okay, this is where I might need to branch out. How do we say we want to open it for writing? Yeah, this is read-only mode. I can look at... We can explore a little bit the dev docs. Rust. Oh, file open. After the name should be options. Okay. I just see a path there. Open options. Okay, there's write-only mode. Create. Open options, open. Okay, so instead of file, it's open options. And then what is it telling me here? Takes 2 arguments. Okay, how come I don't see 2 arguments here? Oh. Okay. It's right here. Okay. Hold on, I'm missing a whole bunch of chat. What did I miss? You had to change permissions just to make your computer not restart every time Microsoft puts out a new patch? Really? Not sure if it'll work, but try putting a cursor after file open, but before the parent, and try pressing Control Space. After file open, but before the parent. I'm not sure exactly what you mean, but like right here? Or inside here? No. Okay, I guess I can just copy from chat. It's open options and then new write true dot open. Okay. I just want to see that it hit that other error. There we go. Unable to open file, permission denied. So I felt like I wanted to test that path as well as this path. And how do we prevent it from being created? I guess we would make the whole directory read-only, right? So I would first delete the file. And I can't because it's read-only. So delete the file, and then I'd make the whole directory read-only, right? Oh, that's interesting. Only applies to files in folder. Okay, I'm not, that's okay. I don't need to figure this out, this Windows stuff. Although cactus, are we in cactus emote mode? The marching left and marching right cacti. Time to sudo. Yeah, that's okay. I know how to do it really quick in Linux. I don't need to figure this out now. I know that what should happen is if we can't create the file, we should go and panic a different way. Just move on. I'm spending way too much time on this. A more seasoned Rustacean might use a closure. I guess that's what this is. Unwrap or else. Yeah, okay. But we're going to get to it in chapter 13. Shortcuts for panic on air, unwrap and expect. Yeah, we've used expect before, remember that. Closures suck? Well, we'll find out. Goombach. Hi, by the way. Also, there was someone new in chat. I detect a new chatter. I'm trying to find where the chat message was, though. I can't find it, so I'm going to use a search. I'm just going to say Kai, because I never know how to pronounce her name. But hi, Kai. That was 10 minutes ago, and I missed your message. I'm so sorry. There it is. Now I can say hi to it. There we go. Found the Rust docs on DevDocs to actually not be that good as opposed to the official docs. Yeah, there were some interactivity elements that didn't work in DevDocs. I'm going to try them both out and see how it goes. Mainly when it comes to traits. Okay. I'll keep that in mind. Hold on, I'm grabbing that. For today. DevDocs versus official docs. That's what, a seagull had to say. All right. Yeah, I like that they have the documentation for all sorts of things all in one place. Unwrap as a shortcut method is implemented just like a match expression we wrote before. If the result is okay, unwrap returns the value. If it's an error, it'll call panic for us. Okay, so they want me to try that. Let's do it. So this becomes just file fook? No, file open. And dot unwrap. And then drop everything else, right? Or am I missing something? Why is this telling me there's an error there? But I have a semicolon there. What am I missing? I don't know. Oh, I still have a match? Okay, thank you, everybody. I don't know, my eyes aren't trained to see that. I think because my eyes are trained, if there's a match or, in other words, a switch in C++, there would be parentheses, and there weren't any. So thank you, Icton Dev and Kai. Compiler did tell me. Oh, there we go. It did tell me in blue, but I was only looking at the red text. There we go. File cannot be found. So that's what unwrap does. Cool. You don't know why you care? Well, one day when my game is officially super popular, you'll have more points than almost anyone playing, and you'll be able to wield your super rare magic sword that you got with those points and say, this is because I helped the developer learn Rust. And everyone will be like, ooh, that's cool. So just look forward to that day in the far distant future. All right. In a perfect world, that's how it would go. Yeah, that's what we saw. Okay. We can use expect in the same way as unwrap to return the file handler call panic. Okay, this is to put our own thing in here. So unwrap just deals with it for us, but expect lets us do whatever we want. So that's an appropriate error message, right? It even includes the error code. Look at that. That's nice. It'd be easier to find in the code, yeah. If we use unwrap in multiple places, it can take more time to figure out exactly which unwrap is causing it. Got it. Okay, when writing a function, its implementation calls something that might fail. Instead of handling the error within the function, you can return the error to the calling code so it can decide what to do. This is called propagation, or delegation is what I would call it. It's like, oh, I got an error. I'll let my employer deal with it. I'll let my boss deal with it. Hey there, JT. You still cared for the virtual points? I think that's a gamer thing. It's just like, wow, I get some points? Neat. How do I get more of those? What are you going to use them for? I don't know. I just want to get those points. Okay, so this talks about returning an error from a function. And yeah, we're just calling. I mean, how does that work? How does return... So return sort of like short circuits out of the function then? F never gets a value because we returned an error. Is that how that works? Just like achievements. Yeah, it's that, was it dopamine? That dopamine ad every time? Early return. So it's a short circuit. Okay. What's kind of weird to me is that it's done in an expression. It's kind of odd to me to see a flow control in a function inside of an expression. Usually I expect that to be only in the context of a statement. But I guess, what, technically the return is an expression? And what? I don't know. I'm just speculating at this point. Do they want me to actually try this out? No, I can just look at it, right? Yeah, that it returns exactly that. So in this case, we don't have to generate a string because we're using the error path, which the string is not used in, right? But it has to, the IO error has to match both of these places. Oh, no, it doesn't. Hold on. Yeah, it does, right? This E has to also be an IO error. Right. I wonder if they're going to get to, like, if there are different kinds of errors, how do you know which one? Yeah. Okay. Propagation of errors is so common that Rust provides a question mark operator to make this easier. The shortcut for propagating errors. Oh, okay. The same functionality. Okay, so whereas this one would shortcut and return the error. So this one does the same thing. If that returns an error, it just shortcuts and returns the error. Otherwise, what? Well, this one had no no value to that, so that's why it's an empty statement. It just puts its output in S and we return that. Okay, I got it. If there are different types, you'd have to do something different. I see. Like making your own type or something, right? Just want to lurk and learn with you, but can I tell you the motivation for learning Rust? I don't know if it's mature enough for jobs. I don't know that or not. It might be, it might not be. My motivation for learning Rust is a lot of my viewers just kept recommending it to me and asking me, have I looked at it yet? And do I like it? And in order to like know if I like something or not, I have to try it out. So I figured, I'll just try it out. And I liked it so much learning it the first day, I decided to keep learning it. If there wasn't a question mark, I'd probably complain about ignoring returned error type. Okay. Probably, yeah, because it's like you would get a result and it's like, what are we going to do with the result? But because we have a question mark, the only kind of result that has data here is if it's an error, right? Because this probably returns an empty tuple if there's no error. And so it won't complain. I think I understand. Thank you for the follows, by the way. From what you heard about Rust, it's something developers want to use, but not so much in the job market. Okay, makes sense. Well, good thing I don't have to do it for a job. I'm just doing it to learn it and to use it myself on my own stuff. Error on the return type is a trait that a lot of people in the community use for propagating errors that aren't of their own library's type. Anyhow error? Okay. Much like job markets still want to use jQuery. Oh, made me shiver too, just seeing that. There is a difference between what the match expression did and what the question mark operator does. Error values that have a question mark operator colon go through the from function defined from the from trait, which is used to convert errors from one type into another. The error type is received and converted into the error type defined in the return type. Oh, that's useful. I was wondering that before, right? What happens if there are two different kinds of errors we might have? That's cool. So that's why. So it's whatever error type we put there, this will get converted to that if it doesn't match. Nice. Eliminates a lot of the boilerplate and makes the functions implementation simpler. We could even shorten it further by chaining them. Yeah, that makes sense. Open and then read. Cool. You want to burn the code base down and literally use any of the framework. Yeah. That's what's difficult about some jobs, right? You have no choice on language or tools that you use. Yep. Yep, oh well. What can we do about that? Wait until the next project starts and be the person in there that says, let's use Rust or Go. And when management says, we've never used that before, you need to give us a cost analysis, then you have to be there saying, I've already done that, sir. This is how much money it would cost if we did it in jQuery, and this is how much it would cost if we did it in Angular. Look how much money we'll save. They'll say, brilliant, do you want a promotion? Interviews ask if jQuery is used or not. And then if they say yes, then you just stand up and walk out. They're like, where are you going? Your resume looks so good. Like, sorry, you used jQuery here. What do you mean go? You want to go away from the project? Yeah. Yeah, that's what a manager would say. You want to use Go? What do you mean? You don't want to be on this project anymore? All right. Okay, it's explaining the chaining, how that works. It can be used in functions that return result. Yeah, that makes sense. Because result is a kind of enum that you could do from on, right? Yeah, okay. Oh, wait. That's because this one doesn't return result, right? Yeah, okay. That makes sense. Two choices to fix the problem. One technique is to change the return type to be a result. The other technique is to use a match. Yeah, that makes sense. That's strange. It's a trait object, which we'll talk about in chapter 17. Okay. Just now read it as any kind of error. Box, I've heard box used in the context in C# of taking a value and putting it inside of an object to be used in different contexts, like using a value in the context of a reference type, like passing by reference, a value type is called boxing. You have a friend who uses jQuery, but you don't even want to write it out, but you've never liked it because there's no good engine. You need to set up deceptive graphs to fool your manager to get them to use Rust. You just tell them that they'll save $10 million or something. Managers like it when you tell them how much money you'll save them. In Rust, it's more like unique pointer of the box. Right, so it's just removing it one reference step. Yeah, I mean, it's the same thing in C# when you box something. You're basically putting it on the heap explicitly, one reference step removed. Yeah. All right. Now that we've discussed the details of panic, let's return to the topic of how to decide which is appropriate to use in which cases, to panic or not to panic. When code panics, there's no way to recover. So yeah, if we can't continue, when we just want to flag it as a bug and stop. Returning a result is a good choice whenever you're defining a function that might fail, like without there being a bug, right? Yeah, prototype code test. I don't even think I need to read this. This is sort of self-explanatory, isn't it? When you have more information in the compiler. Yeah, okay. Let me read this part again. When creating IP address by parsing hard-coded string, you see that that's a valid IP address, so it's acceptable to use unwrap. However, having a hard-coded valid string doesn't change the return type. We'll get a result, and the compiler will still make us handle it. Wait a minute. Oh, I see. Yeah, the unwrap is basically taking apart the result and panicking if it's an error. I get it, yeah. Would you learn Rust as your first language? Yeah, I think Rust is a little bit more rigorous than you'd probably want for a first language. I would still say like Python. Yeah, I'm with the Buff Siegel. Also because Python is immediately applicable to real jobs too. So you can get jobs like in machine learning, for example, if you know Python really well. You don't see it as a particularly good starter language? Oh, for Rust, you mean? I think Rust is just too rigorous. And Python is kind of a combination of... you can do simple things and you can also do complex things. So you can start with the simpler parts of Python and then kind of graduate up to the more complex parts. Whereas with Rust, it looks like you kind of have to know what you're doing to follow all the rules right. You ended up using C++ as your first programming language? Me too, sort of. First real programming language. And that's okay, because it was years ago. We didn't have much. Back in my day, we learned Modula. Modula? I forget what the name is. We learned Pascal, and we liked it. C first and then move to Rust? That's probably a good path, because C has a huge established base. It is closer to the hardware. It has the same compile, link, run model as Rust, and then you can move on and see what's better in Rust. Yeah, Modula. Back in my day, we had to write it in Fortran and put it on punch cards and give it to the computer operator, who would give us our program's result the next day. If we dropped those cards on the way to the computer room, we would have to manually shuffle them to sort them again. How about assembly language? Learn that and all the languages look easier. Assembly language is more like, I don't know what the right word there is. It's simpler in that there are fewer syntactical constructs, but it's a lot less dense. It's very, very light. Like, to do anything of significance, you have to write a lot of instructions. I guess it could be fun. It's a different way of coding. It's like coding at the microscopic level, the way I see it. So you'll end up probably building up lots and lots of subroutines to do anything useful in assembly, right? Completely forgot everything. Assembly is not that hard to remember. It's just instruction and then register arguments and immediate values and indirect references, and that's pretty much it. Subroutines, you mean go-tos? No, I mean jump with link, right? You it's like jumping, like how a rock climber would jump from one rock to another. You set your anchor and then you jump, and then when you make a mistake, you just return back. Yeah, load the value 80 hex into the A register. Store A at wherever register X says to store it. See, guy named Guy, you get the illusion that you know about instruction cycles, but then you get into CPU architecture and you learn that it was all a lie. That one instruction is actually anywhere between 4 and 37 micro instructions, and it depends on which instruction you did. Unless it's an ARM architecture. ARM architectures are pretty straightforward in that, like, usually one instruction is one cycle. But if you look at any, like any kind of, it's like RISC versus CISC, right? If you look at like x86, one instruction could be any number of cycles. And depending on the ordering of instructions, the pipelines could be good or bad, right? Yeah. Assembly language gives you the illusion that you understand the mapping between instruction and cycles, but nope. Yeah, but sometimes people like to do things from scratch, Rust compiler. Hello, by the way. Yeah, the compiler will do it for you, but what's the fun in that? All right. Your code should first validate the values are valid and panic if the values aren't. Hold on, what? I think I'm just going to skip this because this is just a wall of text that's just rehashing what we already know, right? What are they wanting me to do here? Recall in the guessing game where you have to guess a number. We never validated the guesses between those numbers before checking against our secret number. We only validated that it was positive. Consequences are not very dire. It used to be either too high or too low. Okay. One way to do this would be to parse it as an int instead of only a uint, so we don't allow negative numbers. And then add a check for the number being in range. The if checks whether value is out of range, blah, blah, blah. It's not an ideal. If it was absolutely critical, the program only operate on values 1 to 100 and have many functions. This requirement having a check like this would be tedious. So I'm going to make a new type and put validations in the function to create an instance of the type rather than repeating the validations everywhere. That way it's safe for functions to use the new type in their signatures and confidently use the values they receive. Okay. Vector units are very unpleasant mentally to keep hot. Oh, I see, yeah. All right. So it's really just decorating an integer. And I still don't like it when we are explicit with I32. Anyway, I get over that fear or discomfort or whatever. So this is the wraparound it. That new does the range check for us and panics if it's out of range. Otherwise, what does this do? Oh, that's structure initialization, right? Just initialize it based off of the value we got. And this is just like in JavaScript where the key and the value are the same. And then we're making a function called value, which reduces it back to int 32. Yeah, I don't think I need to read any of this. I think I understood that. Yeah, I think we're just going to move on. I want to get to more interesting stuff. Lifetimes. So we are on a new chapter. We are on chapter 10. Traits, lifetimes, generic types. Current task. We're on chapter 10. Traits, lifetimes. Traits and lifetimes. Lifetimes, I know. We're going to deal with life cycles. So duplication of concepts, Rust handles using generics. Generics are abstract stand-ins for concrete types. So functions can take parameters of generic type instead of a concrete one. Right. First, we'll review how to extract a function to reduce code duplication. Then we'll use the same technique to make a generic function with two functions that differ only in their types. Then we'll learn how to use traits to define it in a generic way. Combine traits with generic types to constrain a generic type to only those types that particular behavior, as opposed to any type. Finally, discuss lifetimes, a variety of generics that give the compiler information about how references relate to each other. They allow us to borrow values in many situations while still enabling the compiler to check that the references are still valid. Okay. Overloading. Overloading is where you have this same name used more than once. So yeah, I wouldn't say it's overloading. It's more of defining contracts between objects, right? And making reusable objects where they're parameterized in their type. Overriding. Overriding is technically means like implementing or re-implementing a behavior to be different than the default, right? I don't know if this is more of a pure sense where, like, if the base is virtual, so you're not really overriding, you're implementing. I think that's what they're getting at here, right? Before diving into generic syntax, let's look at how to remove duplication. We'll apply this technique to extract a generic function. Okay, consider a short program that finds the largest number in a list. So here's our list. We start with the first one, then we iterate the list, and we see if the thing we're looking at is bigger than the largest, and we record the new largest. At the end, we know which one it is. I see how this is going. So that works for integers, but most of this would work for anything that determines order, right? Okay, what's different between these two code listings? Oh, they just have another instance of it. Sort of like, let's extract a function to do that. Yeah, largest list, and we're borrowing an immutable reference to an array of ints. And here's the code we extracted out. And then we just call it twice. Makes sense. I think, Levinson, what it sounds like you're talking about is in C++, where you have like a class base and you have a virtual method, void method, I don't know, do something. And then you have another class derived, which is based on the base class, and then you override it. So you have virtual void method override, and then you do something else. That's what that's what overriding means to me. So overloading would be something like this instead, that you'd have another method, but it takes a different argument or something, like method int x, do something with x. Something like that, right? I can't type today. So that's overloading. Overloading to me means the same name could be one of two methods depending on context, like which parameter. Overriding to me means that a base class has a method and then you replaced it with something else. And the modern C++ is explicit with the override keyword. Looks like inheritance, yeah. Overloading is static and within the same class, yes. Overriding is dynamic and occurs child. Yep, Yeah, polymorphism. So I don't know yet if Rust supports that. Oh man, something smells. I don't know what it is. I need to take a break soon anyway. I need to investigate a smell that I just smelt. Man, I wonder if someone's emptying out the trash or something. No, I think it's something in the kitchen. It just all of a sudden was overwhelming. I need to take a break anyway, and I forgot to show this on stream. I'm using Workrave, right? It reminds me when to take breaks. And it's been about an hour and 15 minutes. It's a good enough stopping point. We're going to jump into lifetimes in a minute. Let me take a couple minutes break. I don't think it's the cat. We'll find out. I'll let you know what it is when I come back. I'm going to take like a 3-minute break. Get up and stretch, refill my water glass. Find out if it's the cat that's doing nefarious things. We'll find out. I'll be right back. All right, the smell is overpowering, and I found out what it was. Someone is emptying the deepest, darkest depths of our refrigerator of all the spoiled leftovers. We have a slight problem with too many leftovers that aren't being cleaned out. Couldn't find the cat. I think he ran out when he started when the refrigerator started to get cleaned out. Yeah, my advice to you, chat, is either eat those leftovers before they go bad, or you clean them out early. When you uncover them from the deepest, darkest depths of your refrigerator, you got to be prepared, or else you're gonna get hit by a wave of nausea. Yeah, that's a thing right now. I can't find the cat. I think he's outside lurking somewhere. Anyway. Okay, back to chapter 10, generics. Did I put that in? Yeah, traits and lifetimes. So, actually include that. It's more than this stuff, right? It's generics, traits, and lifetimes. All right. Okay, yeah. This is pretty clear to me. We're just making a function that we're calling twice. Same as in any other language. Okay, a generic type. Considering the function we've extracted, and if we have another one that's exactly the same but with a character, fine. Let me guess, we just put t in there. Okay, so the syntax is we put it in the name, just like in C++, and then we can use it elsewhere. I don't even think I need to look at this too closely. It's exactly the same as what I already know. So, in other words, we define it once with capital T as a placeholder for a real type, and then Rust figures out, based off of the kind of list that it is, here it's integer, here it's character, it knows to use character for the T when we call it here, and int for the T when we call it here. So in other words, taking these two definitions that are exactly the same except for the type and making one out of it. I don't think we need to run into this. Okay, there is an error though. Let me see if I can spot it. It's probably because we didn't say the type. No. Oh, it's saying that in the generic, we don't know if T supports greater than, right? Greater than cannot be applied to type T. T might need to be bound for partial order. Okay. Mentions partial order, which is a trait. We'll talk about traits in the next section. For now, the error states that the body of the largest won't work for all possible types T that there could be. True. Because we want to compare values of type T in the body, we can only use types whose values can be ordered. So do they show how it's fixed then? We learn how to specify the generic type as a particular trait next. For first, let's explore other ways of using the generic type. Okay, so basically they're not going to fix this error until later. They're just going to move to something else. We can also use generic type in one or more fields. So this is generic structure. Got it. That's pretty straightforward to me. Your coordinates are either integers or they're floating point. Would you just implement it on the partial OR? I don't know. They're going to tell us that in a little bit, right? The syntax for using generics and struct definitions is similar to then functions, blah, blah, blah. If we create one with different types, it won't compile. That makes sense. Yep. Expected an integer, but found a floating point. Does the syntax to say T such that T implements partial OR? Yeah, I think that's what we're going to get to in a minute. In enum definitions, you can have a T, which we've seen before with option. Blah, blah, blah. You can have multiple generic. Yeah, you can basically use any kind of name there, and it fits any type. Ah, man, that smell is still around. It's pretty bad. Rotten food smell. Okay. We can implement methods on generic types too, but we just use, you have to have that T again in both places. Doesn't that seem redundant? Doesn't that seem redundant to you? I'm glad you guys in chat are helping out. That's great to see. It's great to see that people helping each other out. Because I'm still learning, and I'm not able to answer all those questions myself. At least not yet. You can have an impl for a non-T. So you could have impl without the T, but with point T. Oh, is that required because we use the T down here? You could have an impl point, no T, and it would work for things like point some function. Oh, so that's only if it needs to be specialized by type. No? 715209 says no. I don't know. We'll find out. No, yes. Well, we'll find out. archaic language? It's a new language, isn't it? Oh, I see what you're saying. Yeah, it's a little bit rusty. By the way, hello, Sai. And actually, while I was on break, also, hello, 25 Blue Money, hello. And I forgot to say hi to Levinson. Your answer was right. Oh, I see. So you don't have to have the T if it's the same for every type. Joke went past head. For me, jokes go right over my head. They don't go past, they go whoosh right over my head. Okay, here we go. We have to declare T just before impl so we can use it to specify we're implementing methods on type point T. By declaring T as a generic type after impl, Rust can identify the type in the angular brackets as a generic type rather than a concrete type. We could, for example, implement methods only on float for point by dropping the T. So yeah, just like the last couple of days, when I start speculating what ifs, it turns out that the next section explains it. So I should just keep reading. So yeah, this means it's specific for a float and not for every type. That makes sense. Okay. Generic type parameters in a struct aren't always the same as those you use in that struct's method signatures. For example, this listing defines the method mixup on point TU. It takes another point as a parameter which might have different types from the self point. Alright, so VW, I see. Okay. Right. And that works because we use U in both places. No, hold on. Why does that work? Wouldn't W and U have to be the same type for this to work? Unless, I guess you could cast them, right? It could have a cast. Okay, here is an example, actually. Yeah, so float and character. How does this work? Oh, it's creating a different kind of point with two different types, right? T and W instead of TU or VW. So it's mixing up the two types. I get it. All right. So you'll get a 5 and a C out of that. Got it. Generic types are declared in impl and some are declared in the given method. Okay, let me see if I understand this. The impl goes with the self. And if you say something here, it has to be the same as here. I'm guessing that's true. And then, but then the name of the function matches its return type. Right? No, it doesn't. Yeah, what does that map to? Okay, this part I don't get. Why do we need a generic specifier here? Is that because it has to match the parameter here? And then this is the result, which is the mix-up. Okay, I don't quite get that. Let me read this in more detail. Define a point that has I32 for x. Okay, no, it's just explaining what I already know. The generic parameters T and U are declared after impl because they go with the struct definition. The generic parameters V and W are declared after mixup because they're only relevant to the method. Only relevant to the method. This is telling me what? That T and U are already defined, but we need to add V and W? I think that's what it's telling me. Within the context of impl TU, we already know what T and U are. We don't know what V and W mean yet, so we have to add them here. And then now we have all four available, T, U, V, and W. So we use V here, W here, and we actually didn't need to use U, because I guess it's implied by the self X. Or, no, we don't even need to, didn't need to use U. Look at the let P3 equals P1 mix up P2. I'm looking at it. What I don't get is, or I don't know if I get for sure, is what types are listed here and why. P2 are strings, yes. It's the same as in C++. You can have template method for a templated class. That, I haven't really ever gone that deep into templates in C++. That kind of stuff is scary. That's maybe why I'm having trouble here, because this is getting a little bit ridiculous with generics. I mean, it's a contrived example. V and W go for the other point, but it's the other point as in the argument, not the return value, right? So that's my guess, is that the types you list here either are the ones that are for the argument or they're the ones that are not in the impl. Anyway, I guess I'll if I see another example, I'll probably understand a little bit better. Performance of code using generics. You might be wondering what the runtime cost is. Good news is it implements in a way that code doesn't run any slower. Yeah, it just does it all in compile time. Performs monomorphization. Monomorphization. I never heard that word before. The return value uses T from the point TU type and the W from the argument. Yeah, I got that. I know how the mix-up works. Is it's making a new kind of point type where it takes the T from the left hand and the W from the right hand. The part that I don't understand is why do we have to list V and W here? Right? Is it because we use V and W here and they're not in the impl? That's my guess, is that we have to list all type parameters that are not yet in context. So T and U are already in the context of that, so we're listing the ones that aren't in context next. Okay, I think we're all sort of in agreement. In enough agreement. Until I'm proven, I don't have to have it right. I can be proven wrong later. That's fine too. So monomorphization is the process of turning generic code into specific code by filling the concrete types that are used when compiled. Yeah, that makes sense. Doesn't C++ just call that instantiation? All these fancy words that mean the same thing. So it reads the values that are used, and so it even uses the word instance, like instantiation. Expanding the generic, it's not that it expands the generic definition, it's that it makes two instances of it. Or whatever. It's replaced by two instances of it. Got it. We pay no runtime costs, but you get a small explosion in code. Get copies that way. Big words make Rust smart. That's fine. They're allowed to do that. It's one of the perks of making your own programming language. You can invent words that make you look smart. That's fine. Hey there, Pomp Rocks. How are you doing today? And also, I saw some chat from someone else. Null pointer reference. Do you just work through the book or do you have a project you want to build? Right now, I'm just working through the book, null pointer reference. The project I've been working on for the last year is this game. And as I've been working on this game, looks like this, by the way. As I've been working on this game, whose backend is mostly in C++, a lot of viewers have commented saying, have you considered using Rust instead of C++? Do you like Rust? How would this run better or worse if it was in Rust? And I was always struggling for an answer because I didn't know anything about Rust. And then another streamer who I respect started using Rust on stream and started talking about it, and I, got to the point where like I would at least like to know a little bit about Rust to know whether or not I should be using it, and decided why not learn this live on stream. So I'm taking a break right now, working on this game to learn enough of Rust so that I can decide for myself, is this something I want to use? And if so, do I use it in my current project? Or maybe do I have it sit there in my brain and in my notebook until a new project comes up and maybe a new project would fit Rust better? I need to decide that. If I end up using it in the game, I'm not going to rewrite the game's engine in Rust. What I'll probably do is any new code I add would, if it makes sense, I'd do it in Rust, and it would interoperate with the existing engine. So my style of learning this week is just a personal decision. I decided I was given a whole bunch of links by Chris Griffin, who is one of the people I respect that knows Rust. And he gave me the link to the Rust book, the Rust Up, and also 2 other links which are geared towards how Rust is used for web dev and how Rust is used for game dev. And I decided I would start with those links, the Rust book being primary, and just walk through them. And so as I started walking through the book, I'm like, oh, this book is explaining the entire language to me. So I'll just walk through it like anyone would if they are reading from a book, and sort of do that live. And that smell is still around. Doesn't Rust also compile C++ code? I don't think so, but the hope would be that you could take something like a.rs, run it through the Rust compiler to get some kind of object, and then like b.cpp, go through the C++ compiler to get another object, and then these 2 objects would be linked together to form the executable. So kind of like that. Form one library or executable. So I don't know how to do the combining to make one library executable yet, but I'm hoping that's what I can do. But if not, maybe another level of reuse would be that we have a library, and we have our C++ as an executable, and then that executable uses that library. So definitely they're different compilers, but my hope is that once they're put into object form, that they can be linked together. And if not linked together, we can at least utilize them through some kind of API wrapper. This is the how I mix C# and C++. Is I'll make C++ libraries and C# executables using pinvoke to call C++ libraries from C# assemblies. So that's not the best solution. The best solution is if they're completely linkable. You know, you can link them to one executable, you just don't know how easy interoperating is. You've seen posts about people doing it in the community? Okay. Much like you took some time to learn Node.js and all of a sudden this dno was talked about. I see. Honestly, I wonder if you want to continue with C++ and say a couple years go by, and by the time you want to do a new project, something brand new is sought after or is recommended over Rust. Yeah, we'll see. We'll see. Things are very contextual and they change over time too. All right, back to traits. Okay, I had just finished generic types. We're moving on to traits. Got it. Okay. Trait tells the Rust compiler about functionality of a particular type, has, and can share with other types. We use traits to define shared behavior in an abstract way. So in other words, it's an interface. I think we already know that, right? Trait is interface. I think Rust is playing the long game. We don't see it being just a flavor of the week. It's been around for a little bit now, right? Yeah, trait is basically interfaces. You need to use C interface when linking Rust with C++, but that's more or less expected with most languages mixing. Yeah, that's fine. I'm used to that, and I'm fine with that. I use one library to help me do some of that stuff. The Swig library. Simplified wrapper interface generator. So actually, I wonder if they even have something in here to do Rust. Nope. maybe because it's actually not needed. So for languages that are not directly callable from each other, like if you wanted to call C from Java or Python from C++ or Python to C#, I think you still have to go through C, but this Swig thing helps you wrap the two together. Anyway. Types behavior consists of the methods we can call in that type. Different types share the same behavior if we can call the same methods. Trait definitions are a way to group method signatures together to define a set of behaviors necessary. Let's say we have multiple structs that hold various kinds of amounts of text, a news article, a tweet. We want to make a media aggregator that can display summaries of data that might be stored in a news article or tweet. To do this, we need a summary for each type. And we need to request that summary by calling summarize. So that's a trait. Okay, so it's exactly what I would expect for an interface. It looks like a structure, but it doesn't have any data or bodies of functions. Rust Swig, a tool for connecting programs or libraries written in Rust with... Oh, cool. Let me make a note of that. Hold on a sec. All right. Viewer contributions. Someone 5209 says to look at Rust Swig. We'll look at that later. Thank you. 715-209? Because I am going to want to interoperate with C++ if I can. Okay, we declare a trait with the trait keyword and then its name. So it's like struct or class. We have method signatures. Got it. Instead of providing an implementation within curly braces, we use a semicolon. Yeah. Trait can have any number of methods. Implementing a trait on a type. Here's where we get interesting. Here's where it gets interesting. We know how to declare a trait. How do we implement a trait? So it's an implementation of the summary trait in the news article. Oh, guess who's ascending the tower? He's on his way. You can see it shaking. There he is. It's the cat of the year. We're going to just see his back, I guess, because he's just standing and observing out. Oh, there he's turning around. Now he's getting comfy. He's got to do the 720 spin. Maybe he'll do 3 revolutions. Okay, he's stopped. Finally, you can see me pet the cat. Yes, you can. Let's go do it. There we go. The cat gave me a little greeting of approval. Turn my camera back on. There we go. Pre-recorded cat petting, indeed. Hey there, M. Perry. Oh, and Mr. Halsey is here. And that noob is here. All these people I forgot to wave to. And Aodine. I don't know if I'm saying that right, but hello. Where is your message? I can't even see it right now. AOD. Oh, right. I can do this. Traits are basically interfaces. Yes. Hello. Okay. Here's our struct. Okay, it's implement trait for struct. Got it. Oh, that's easy. Well, that's easy. Non-pleb here? None of you guys are plebs. You all are valued viewers of the members of the community. Implementing a trait on a type is similar to implementing regular methods. The difference is that after implement, we put the trait name we want to implement, then use the for keyword, then specify the name of the type we want to implement it for. Within the block, we put the method signatures for that trait. Okay, and then we can use... So self sort of binds to the type, and summary binds to the signature. I got it. Non-pleb? Exactly. So that means there's a Perry 0 somewhere out there who's a real pleb. N-Perry is the non-pleb version. Right? After implementing the trait, we can call methods on instances in news article and tweet in the same way we can call regular methods. So here it was summarize. Yeah, so we can just call it. Note that because we defined summary, trait, news article, and tweet types in the same library, they're all in the same scope. Let's say this is for a crate we've called aggregator. Someone else wants to use our crate's functionality and implement the summary trait on a struct defined in their library scope. They would need to bring the trait into their scope first. So this is the part I don't quite like. That you have to pull in the trait to use methods defined by the trait is sort of weird to me. It'd also need to be a public trait for the crate to implement it. Yeah, so we have to use the pub keyword. One restriction to note with trait implementations is we can implement a trait on a type only if either the trait or the type is local to our crate. That makes sense. Like, to implement someone else's trait on someone else's type would be extending that type maybe in a way that is not supposed to be allowed. We can implement standard library traits like display on a custom type because that type is local to our crate, but we can also implement our own trait on a vector because the trait is local to our, because the trait is local. We can't implement display on vector because neither one is in our crate. Okay. It's called coherence, the orphan rule, so named because the parent type is not present. Okay, thank you for the follows, by the way. I'm getting several of them. Well, you found someone who's learning Rust? Yeah. And I have a C++ background, so I'm trying to, as I go, I haven't done this much today, but I've been writing down notes about what's different that I found between C++ and Rust. So this was what, day 2? Wait a minute. Do I have a copy of that? No, that is day 2. Yeah, I got confused between day 1 and day 2. For example, I'm writing things down like value assignment is always a move, just like in C++ move assignment. So it's sort of the default is move, whereas in C++ the default is copy. And then there's this caveat: if the type has a copy trait, it's just like C++. Just catch up your main reasons for learning Rust, and how do you feel compared to C++? Yeah, again, the main reasons for me to learn Rust are that a lot of viewers, as I've been developing the game that I'm working on, that, by the way, looks like this. This game that I'm building, the back-end engine is in C++. And a lot of viewers say, "What have you considered Rust? What do you think of Rust? Do you like Rust?" And I kept having to say, I don't know anything about Rust. So I thought I would learn a little bit about it. And what better way to learn about it than to just go through the book that's designed to teach you it. So that's what I decided to do live. And how do I feel about it compared to C++? I like everything about it so far, and these are the only things I don't particularly like. The fact that we see exact integer sizes in names of types used in the book mostly. The snake case opinionated naming convention, and the one we just ran into again, where in order to use methods from a trait, you have to pull in the trait, and it's not immediately obvious to a casual reader why the trait is being pulled in. Like the example we were looking at first was it in Guessing Game? Yeah. In order to use gen range, you have to pull in the RNG trait, and that's because if we were to control-click gen range, we'll find that it is defined within the RNG trait, right? But it's not immediately obvious to a casual reader of this code. When they read this line, there's nothing here that says RNG trait. And if you're reading this line, there's nothing here that says we need this to get gen range. So to compensate for that, I decided I would put a comment here saying, we need to use RNG for the gen range. It's interesting, Rust for games since C++ has been dominating that industry. Yeah, well, we'll see. New things in the game, healing potions. Yeah, you've missed a few things, A squared. I'm not sure how to say your name, but hello, Beliarly. Beliarly? Beliar. I don't know how to say the name, sorry. I just butchered the name three or four different ways. And hello, Twitch. Hello. Anyway, I hope I explained why I'm looking at Rust. I want to at least understand what it is and then evaluate, is it something that I could use instead of C++ in some context. Just Beliars, okay? Okay. Welcome. So I'm learning about traits. Traits are, to me, being used to C++, the trait reads almost exactly the same as a pure virtual base class or an interface. Only it's a little bit more flexible because we can attach it to newer things, as long as we as long as we meet what they call the orphan rule, that we can only make implementations of traits if either it's our trait or our type that we're implementing the trait on. which is that's fine. That's an acceptable rule, right? Okay, default implementations. Oh, so if you put a body of code in the trait declaration, it becomes the default for anything that implements the trait. That's useful. Yes, the beast is there. I will pet the beast. Thank you for redeeming those points. He is my stream companion. He is Casper, my master. I must feed him whenever he requests it, and give him pets occasionally. All right. You're also currently learning Rust, but a bit further ahead in the book. Yeah, I'm a little bit behind. I'm going slow, mostly because I'm trying to be thorough, and also I'm interacting with chat a lot, so. My apologies if you think I'm too slow. I'll try to kind of pick up the pace in certain parts. And if I skip things that you'd rather me cover a little bit better, let me know. Some things I'm skipping because they're just so close to what I already know. Like a lot of that error stuff, like it just made sense to me. I didn't need to look at the detail. It can be just a little bit, but you guys are awesome, you know? Right, so default implementations, that just makes sense to me. I don't even think I need to look at this anymore, right? Provide a default implementation so we can do summarize. Yeah, okay. Yeah, I don't need to know this, right? Yeah, we can just call summarize without implementing the trait because it's in the default. Doesn't require us to change anything about it. The reason is the syntax for overriding a default implementation is the same as the syntax for implementing a trait method that doesn't have a default implementation. Hold on, what did that say? Creating a default implementation of summarize doesn't require us to change anything about the implementation of a summary on tweet. Oh, because the syntax is the same. Got it. Default implementations can call other methods in the same tree, even if those other methods don't have a default implementation. Right, C++ lets you do that too, with templates. Actually, did you even need it to be a template? Yeah, I think it was when you used a type as a template, you can use methods on that type even before you've instantiated that template. All right, so that's summarize author, so that's supposed to be provided by whatever implements the trait, and there's no default for it. I got it. After we define summarize author, we can call summarize, but we can't call summarize if we don't have summarize author, right? No, that it isn't possible to call the default implementation from an overriding implementation of the same method. Yeah, because you're overriding it. All right, that's fair enough. Traits as parameters. Yeah, well, this makes sense to me that you can just use a trait as if it was a type, right? And then any type that implements a trait will fit there. Yeah, summary. I don't think I even need to go into it. It just works. It makes sense. The impl trait syntax works for straightforward cases, but it's actually syntactic sugar for a longer form, which is called trait bound, and it looks like this. Function notify t summary. Oh. Annotating the generic parameter. That makes sense. So this is like in C# where you have to say in a generic you don't have to, but if you wanted to narrow the scope of the generic, you would say that T has to be implement summary. Yeah. And that allows you to do a little bit more than if you didn't bind it or narrow its scope. Impl trait syntax is convenient and makes for more concise, simple cases. The trait bound syntax can express more complexity in other cases. For example, we can have two parameters implement summary. Using the impl trait looks like that. If we wanted to allow item 1 and 2 to have different types, using the trait would be appropriate as long as both types implement summary. If we wanted to force both parameters to have the same type, that's only possible expressed using a trait bound like this. Yeah, so if item 1 and 2 have to be summaries... Actually, no, I don't understand this. Oh, it constrains it so that the concrete type fill-in for T has to be for both item 1 and... Oh, I get it. So this, they both just have to be something that implements summary. Here, they both have to be the same type, and the type is something that implements summary. But they have to be the same. Here they don't have to be the same. They could be two different things that implement summary. I got it. I got it. Cool. Multiple traits with the plus syntax. Oh, well, that's interesting. I've never seen that before. That's new. I think in C# you use comma or something instead of the plus, right? So it's also valid with trait-bound types. Got it. Okay. That's kind of funky, but I can roll with that. Because plus, I've never really seen it used for anything else within generic type specifiers, so fine. Now we're in the deep end. I'm okay with this though. I mean, it makes logical sense to me. This is basically saying that this item that you pass to notify needs to implement both the summary trait and the display trait. So it needs to have a summary and it needs to be able to display it. I mean, they're just constraints. You can think of them as constraints. That you're constraining the type T that it has to implement these two traits. Yeah, I get it. One of your favorite features of Rust? It's pretty cool. C# has something similar in their generics. So it's not completely new to me, but the plus is kind of new. It's just a different syntax. Using too many trait bounds has downsides. Yeah, you can over-constrain things, so that's like unusable. So functions with multiple generic type parameters can contain lots of trait-bound information between the name and the list, making the signature hard to read. Okay, I guess that's one downside. Rust has an alternate syntax for specifying trait bounds inside a where clause. Ooh. So here we have T that has to display and clone, U which has to clone and debug. And the where... Okay, it's just basically taking the annotations and putting them somewhere else. So you can read the signature a little bit easier. And then you put it between the return type and the body. Okay, that might take some getting used to for me. The more programming languages you know, the easier the new ones are. Yes, so I think I said that early on in day one, that this is easier for me than it would be if I learned Rust from scratch, because I'm looking at everything through a lens of experience of looking at a few other languages. And so I'm constantly drawing parallels. Like, this is like a generic in C# or a template in C++. And then I'm really just focusing on what's different. So like the plus here is different. The colon here is different, right? But I can, in my mind, mentally map the concept to what I've seen before, and just, it's like there's a mapping made to what I already know to what's new, with a little bit of difference attached to onto the side. And I've in my notes I've been like doing this a few times where I know I'm gonna mess up. So like for example, match is like switch, but lacks parentheses, because I know I'm gonna mentally, if I make an association between match and switch, it's like, okay, I want to switch here. What is that in Rust? It's a match. And I'm just going to naturally, through muscle memory, type parentheses, right? But then this note is trying to remind me, no, you don't use parentheses around arguments or expressions. It's not really an argument. Around its expression. If I forgot to do that, Rust is nice and will give me a warning, but this is the difference between the languages, right? Another thing is, in C++, I'm just used to typing the word case. Instead, we're going to use arrows, right? And then I need to remember that in Rust, the whole thing is an expression. It's not just a statement. And so every arm should return something, as in evaluate to an expression whose value will be returned if that arm is chosen. So I wrote this on purpose because these are the differences. Everything else, though, that I know about switch applies to match pretty much, right? Anyway, that's what I've been doing. But you tell people to learn different paradigms to cover a lot of ground. Yeah, it gets easier because you start to just make associations between languages. And Like fn is def in Python, right? Or function in JavaScript. So it all means the same thing with slight differences. It's less cluttered because we put the trait bounds by themselves off to the side. Sure. Returning types that implement traits. Probably the same thing, right? We can use it on the return. Right, we can just use it there. Oh, but we have to use the word impl. Okay. That's different. Okay, I need to write that one down. I'm going to forget that one and screw that one up. So my observations, Rust compared to C# is that when returning an interface trait, we need the impl keyword in front of the trait. Because I would have not put the impl there. I would have just said arrow summary, and that would make sense to me. But that's probably because of a syntactical reason. It's the same as the other impl. The other impl, I thought it was just a placeholder for... because we used impl before when we had structures, right? Where did I do that? Restaurant. Source, one of these. Didn't I have something that had an impl in here? Maybe not. Maybe I didn't include that in the code. Did I not have any impls in any of these? Yeah, I don't think I actually typed any of it. Yeah, oh well. There's impl trait and dyn trait. Ooh. The example referred to had and impl summary twice. All right. Let's trace as parameters. Okay, keep going. Returning types. Right, so tweet implements a summary. Returns summarizable function, returns some type that implements summary trait without naming the concrete type. Yeah. The ability to return a type that is only specified by the trait implements is especially useful in the context of closures and iterators. Create types that only the compiler knows, or types that are very long to specify. Oh, sure. Lets you concisely specify the function returns some type that implements the iterator trait without needing to write out a very long type. That's interesting. Never thought of it that way. However, you can only use impl trait if you're returning a single type. For example, this code returns either a news article or tweet with the return type specified as impl summary wouldn't work probably because it has to actually bind that when it compiles it, right? So it's not exactly the same as an interface in C++. Right. We'll cover all this. So I should make that a note too. Returning an interface, we need to the impl, right. Returning a trait. I should switch this around. I should say when returning a value implementing a trait interface, we need the impl keyword in front of the trait. Returning a trait, well, meaning returning a value which implements a trait, requires the implementation to return a specific type implementing that trait. We can't have for example conditional logic that returns either of two types that implement that trait. Okay, good to know. I'm writing it down to cement my knowledge. Can't return a pure abstract classified value in C++ either. Right. You would to return it by pointer or reference, right? Yeah. So I kind of get that because they are not references, they're values, it still gives us the flexibility of not specifying what exactly we're returning, but we do have to return only one type, and that's why this is bad, because which one is it? It depends on something at runtime, and they needs to know a compile time because it's a value type. I get that. So I think what you're suggesting, Kai, is that if this was a reference, we could make it work. But I don't know. We'll find out. The same way in Rust you can return a reference to trait or a box dynamic trait. Okay, so yeah, so I think you're saying that yes, you could if it was by reference. We'll find out. We'll cover how to write a function with this behavior using traits that allow for different types in chapter 17, and we're only on chapter 10, so it's going to be a while. Fixing the largest function with trait bounds. Right, so this had that problem. They're going to tell us just specify that it T implements the partial OR trait, and then it will compile. Wait, we get a different set of errors. Cannot move out of the list, which does not what? Implement the copy trait. Oh, right. So we're gonna say it needs to be copyable. Yeah, they implement the copy trait. So basically, yeah, we have to add copy. That makes sense to me. I was about to say they're probably going to add the copy trait to the specification, and then it works. Neat. If you don't want to restrict it to copy, we could specify it's clone instead of copy. That would clone each value. It could be slow because we have to duplicate it. Another way would be to use a reference. Yeah, I was just about to say that. Using trait bounds to conditionally implement methods. What does that mean? Using trait bounds to conditionally implement methods. Don't know yet. By using a trait bound with an impl block that uses generic type parameters, we can implement methods conditionally for types that implement the specified traits. For example, the type pair always implements a new function, but pair only implements compare display if its inner type implements partial ORed that enables comparison, and the display trait enables printing. Okay, so it's in the impl for a type, a generic type, if you list traits. I get it. Okay, so that means that you only get comp display for T's that implement both these traits. Okay, that makes sense. You can also conditionally implement a trait for any type that implements another trait. Okay. This is getting deep. I think this is getting pretty deep. What do you guys think? Thank you for the follows, by the way. I didn't say hi to St. Lucifer. First one looks like TypeScript, second one like C#. Look, I got 4 hands. Oh, you can only see 3 at once there, but you get the idea. Hey there, St. Lucifer. 4-hand example. Okay. 4 hands. See? Anyway, enough fun. Implementations of a trait on a type that satisfies the trait bounds are called blanket implementations. All these terms that we're learning. Cheesegee, Ava Siegel, don't be afraid. It's not really 4 hands. It's my Raimu spawn. I got kids that wander around the house, and they will periodically pet the cat too. Do not be alarmed. Blanket implementations are extensively used in Rust standard library. For example, standard library implements toString trait on any type that implements the display trait. The impl block looks similar to this. So we're implementing for a type, any type that implements the display trait, the toString trait for T. Okay. I got lost there. I need to rewind a little bit. What was that 4 keyword for? I think I'm going to need to write this down. The 4 keyword was used somewhere. Where is the first time we used the for keyword? I think I went maybe a little bit too fast. Oh. Was that in the previous one? No, here it is. It's implementing a trait for a specific type. Okay, I need to write that down. Because I forgot already. Implementing a trait for a type involves a special impl block similar to how methods are implemented. Or methods are defined for a type, where we add for t, where t is the name of a trait. Name of the trait. Yes. Can you implement on enums? Yep. Yep, I think we saw that's true for... what was it? Expect or something like that? Expect is something that's attached to the result enum. Yeah. All right. So back down. Where was I? Okay, I was just through that one. We refixed it. Implement methods. Yeah, we got that. No, that's what we were on. So stop searching. Stop searching. Where's my search thing? There it is. Okay, no, I did get through that one. This is what threw me, right? We can conditionally implement trait for any type that implements another trait. Okay, so we're implementing the T trait. Did I get it backwards? Oh, I see what it's doing. I think I got it. We're implementing for all types that implement the display trait. We're implementing the two-string trait for every type that implements the display trait. That's really wacky. Okay, I need to write this down explicitly. So this is some next level beep. You can even implement a trait. You can implement a... What exactly are we doing here? You can implement a trait on any type that implements another trait. You can even specify methods which apply for a trait on a type that implements any type that implements another trait. Find using a where clause in this situation a little bit more readable. Yeah, I found this extremely difficult to read. I'm gonna have trouble with this one. That's why I am gonna put this as an explicit example here. Whoops. Cursor there, paste code. So that as in that means we're about to specify methods you can call on any type T which has the display trait. We're going to specify two-string trait methods you can call on any type T which also has the displayed trait. Did I get that right? means we're about to specify two string trait methods you can call on any type T, which also has the display trait. Okay, I'm having a really difficult time. You guys tell me if I got it right. Import T to string for T where T is display. Yeah. I'm going to have to mull this over in my head a little bit more. Because the standard library has this blanket implementation, okay, that's a keyword. This is called a blanket implementation. We can call the toString method, defined by the toString trait, on any type that implements the display trait. For example, we can turn integers into the corresponding string values like this because integers implement display. So because 3 is an integer and integers implement display, we can call toString because I'm guessing toString is a method inside of this snipped area. I got the essence of it. The above might be a little bit more understandable to humans. Yeah, let me take ectondev's example and say that ectondev gives provided this example alternate syntax, which is perhaps easier to get. There we go. Normally the where clause is on the next line. Yeah, I get it. It's just where you put your white space, right? Like implementations also appear in the documentation for the trait in the implementers section. All right. Traits and trait bounds let us write code that uses generic type parameters to reduce duplication, but also specify the compiler we want the generic type to have particular behavior. Compiler can use the trait bound information to check that all concrete types used with our code provide the correct behavior. So it's more of the rigor of the language. Dynamically typed languages, we would get an error at runtime if we called a method which didn't define it. But Rust moves these to compile time, which is how it gets its speed. But it forces us to fix it before we can run the code. We don't have to write code that checks for behavior at runtime because we've already checked it at compile time. Yeah, improves performance. Another kind of generic we've already been using is lifetimes. Okay, here we're going into the third part of the chapter to figure out what the heck a lifetime is. Validating references with lifetimes. One detail we didn't discuss when borrowing is that every reference has a lifetime, which is the scope for which that reference is valid. Most of the time, it's implicit and inferred, just like most of the time types are inferred. We must annotate types when multiple types are possible. In a similar way, we must annotate lifetimes when the lifetime of a reference could be related in a few different ways. It requires us to annotate the relationships using generic lifetime parameters to ensure the actual references used at runtime will definitely be valid. I think I get this. I can think of some scenarios in C++ where I've had to consciously validate by code inspection that, or by using smart pointers, that an object would stay valid for the entire scope in which I used it. So I'm guessing Rust just lets you annotate to solve that problem too. That would be neat. More distinctive feature. Yeah, although we won't cover lifetimes in their entirety, we'll discuss common ways. Okay, dangling reference. You can watch this if you need more explanations of lifetimes. Oh, thank you, 715209. That is a viewer contribution. Thank you very much. Okay, we don't want dangling references. Consider this program. We have a variable x, and we bind r to be a reference to x. And then x goes out of scope. What is r? We would get a compiler error because it would just tell us that it went out of scope, right? What is it saying? They declare variables without giving them an initial value so that it exists in outer scope. At first glance, it might be in conflict. Right, but it's not because we didn't use it before we assigned it, so that's okay. That part is okay. But what's not okay is that the lifetime of r extends beyond x, but it has a reference to x. I'm actually curious what kind of error we would get if we tried this. Are they going to tell me what the error is, or they are going to tell me? So I don't need to try it myself. Borrowed value does not live long enough. That's a nice error message. I like that. It's to the point and it's precise. X dropped while still borrowed here. They even tell you where it gets dropped. Borrow later used here. That's neat. And they even say, if you want to know more, explain this error to me. Okay, cool. Hour and a half. What's hour and a half? You find the borrow errors are very helpful in practice? Yeah. Yeah, we know the reason. The borrow checker. Okay. Rust compiler has a borrow checker that compares scopes. So this is just how the compiler works. A little bit of insight. Yeah, we don't need to know this. It's smart. We can just know that it's smart. So to fix it, to have no dangling reference, we just make its lifetime in the same scope. All right. Got it. Yeah, they are very well written. I'm very impressed so far. Video on lifetimes is an hour. Oh, the video on lifetimes is an hour and a half. You know, that's okay, because sometimes you want to just get out a bag of popcorn and drink, and you just want to sit back and relax and watch a video. I wouldn't mind learning something about programming while snacking on popcorn myself, so, you know, why not? But I would definitely save it to where I have an hour and a half to watch it, I think. I forgot to say hi to Cheesegi. Hello. Definitely you've watched it? Yeah, so I'll just add it to my watch list. Now you know what I'll be doing on my off time at some point. I'll be watching that video. All right. 2 longer slices. Oh, no. We're writing a function that returns the longer of 2 slices. It takes 2 string slices and returns a string slice. It should say the longest is A, B, C, D. Note that we want the function to take 2 string slices, which are references, because we don't want the longest to take ownership of the parameters. Right. We want to allow the function to accept string slices as well as string literals. Yes. Refer to that if you want to know why the parameters we use are the ones we want. Yeah. If we try to implement the longest, it won't compile because it's going to say that we're returning a reference that we no longer have, right? The function's return type contains a borrowed value, but that signature does not say whether it's valued from X or Y. Oh, because it needs to know at compile time and not runtime. We only know if it's X and Y at runtime. So it says, well, which one are we returning? What's its lifetime? I got it. But yeah, again, another neat error message. It says, I need to know what the lifetime of that is. You didn't say it, but it's either X or Y, or something else, I guess. Or you can't tell the difference. Okay, so the annotation, the lifetime annotation syntax, they don't change how long any of the references live, they probably just tell the compiler what the constraints are, right? They describe the relationships of the lifetimes of multiple references to each other without affecting the lifetimes. Got it. Slightly unusual syntax. The names of lifetime parameters must start with an apostrophe and are usually all lowercase and very short, like generic types. Most people use the name A. A. We place lifetime parameter annotations after the reference using a space to separate the annotation from the reference's type. Okay, so it's reference apostrophe A space and then the rest of the type name. Okay. One lifetime annotation by itself doesn't have much meaning because the annotations are meant to tell Rust how generic lifetime parameters of multiple references relate to each other. For example, let's say we have a function with a parameter first, that's a reference to an integer with a lifetime of A. The function also has another parameter called second. That's another reference to an i32, also has a lifetime. Lifetime annotations indicate the references first and second must both live as long as that. Oh, I see. So that's why they introduced us to this concept of what the compiler does and why they named it A and B. Because those are just lifetime scope specifications. I get it. I get it. Yeah, exactly. We could have used Fibble-de-Gidget instead of A, but A is nice and short. Right? That's why they said it here. I was wondering why they say most people use the name A. Yeah, it's saying like, if you have first and second and they're both A, that means they both live at the same length of time. Right, so if you say X and Y are both within the same scope of lifetime and you're returning the same scope, it's like, okay, then we're cool. We're cool. But if you had X as A and B as Y, then this would say, if by A you're saying, well, it has the same lifetime as X. And if it was B, you'd be saying it's the same lifetime as Y. I got it. Tells Russ that the string slice... Yeah, exactly. Got it. I've started noticing a pattern in how I'm learning through this book. I read up to a point, and then I make an extrapolation to see if my understanding is correct, and usually then the next paragraphs confirm or deny that I understand it correctly, which I kind of like. Although I hope you guys don't find it too annoying that I'm basically predicting what the book will say next, and then when the book says what I was thinking or close to that, then I'm like, yay, I understand it. Okay, yeah, this is just explaining everything we just said, right? Yep, okay. Let's look at how lifetime annotations restrict the longest function, passing references that have different concrete lifetimes. Okay, so we have string 1 that lives longer than string 2, and we do that, but then we use it, that's fine, because of what reason? Because the compiler knows the relationship between string 1 and string 2's lifetimes, right? It approves of this code because both A and B fit. Both string 1 and string 2 fit the definition of A. A. Find it annoying? Isn't that the normal way of learning something? I mean, I hope viewers don't find it annoying that I'm doing it and not just reading through it and saying, okay, I'm done. Why are they doing it as string? Isn't that just a way to get a slice from the string? I can look that up. Extracts a string slice containing the entire string. So it's just syntax. It's just a way to get a slice from a string object. Probably so they don't have to mention the as ref trait. Okay. Yeah. The original slice has a static lifetime. Yeah, so I'm just saying yeah because what you're saying sounds correct, but I'm out on a limb. I don't really know. Okay, back to here. Maybe they'll explain why they're using asstring, or maybe they'll leave it as a mystery to be explained by you guys. So Buff Siegel is correct. Okay, so the original slice has a static lifetime. So if you just did a slice of it, it would have a static lifetime, so it wouldn't fit their it wouldn't work in what they're trying to describe. They're trying to describe things that have non-static lifetimes, right? So I mentioned about standard Rust query searches the standard library docs for query. Oh, I don't think anyone mentioned it, so I'll give you a point. That's another viewer contribution. Next, let's try an example. It shows lifetime of the reference and result must be the smaller of the two. So here, yeah, here they do the print outside the scope of string 2, and you're going to get an error because it's going to say it doesn't live long enough. Yeah, borrowed value does not live long enough. See? I'm understanding. And that works because of those lifetime specifiers on the parameters and return value. Cool. That's okay. We don't need to do more experiments. I think I got it. I'll watch that hour-and-a-half long video to make sure I got it. Okay, thinking in terms of lifetimes, the way in which you need to specify lifetime parameters depends on what your function is doing. If we changed longest to always return the first parameter rather than the longest, we would need to specify a lifetime for y. That makes sense. So basically telling the compiler that the constraint is only on the x. Got it. Although, you know, it makes me wonder, why can't the compiler figure it out on its own? This part. Can't it go through all possible paths and know that X and Y, since they're both A, that this must be A? Why do we need to specify this A here? You know what I mean? We already said that X and Y are both the same lifetime. And it should see through the abstract syntax tree that we're always returning either X or Y. So why do we have to say that on the return value? Maybe just because the compiler is not smart enough? It does do that. As you go further, you'll find that lifetimes can be elided. Okay, so this is not required then here. Let's verify. Trust but verify. So I can maybe make a function here where we do that. And then I can just drop that and see what it does. No, I didn't like it. Didn't like it. What didn't like about it? Missing lifetime specifier. Okay, so maybe there's a way to do it, but yeah. It's not smart enough to get it by itself. I can remove the others. Really? I just noticed something. I didn't notice that before. It's specified almost as a generic. Is specified. Anyway, you're saying I can, well, I can remove it here, but if I use it, it would be a problem, right? Okay, anyway, I'll just leave that and play with it later. You think it needed it? I'm doing too much speculation. Down here. Okay, we're on... Okay, here's something new, right? When returning a reference from a function, the lifetime parameter for return needs to be matched to the lifetime parameter of one of its parameters. If it does not refer to one of its parameters, it must refer to a value created within this function, which would be a dangling reference because the value will go out of scope. Now, that makes sense to me. In early versions of Rust, you had to explicitly specify lifetime more often. As the compiler got improved, more and more cases were handled automatically. Okay, fair enough. Underscore could be used instead of A? I suppose so. It's just a name, right? It's an arbitrary name. It could use fibbledy-gidget. Right. We can't do that because it is a reference. Even if we said it lives as long as A and we're lying, right? Problem is that result goes out of scope and gets cleaned up at the end of the longest function. We're also trying to return a reference to result from the function. There's no way we could do it to make it work. In this case, the best fix would be to return an owned data type rather than a reference, yeah. Underscore is a reserved name? Oh, it is? Okay. Cool. Give you a point. And Mr. Halsey saying underscore is elision. Another point. Where's the other one? There we go. There we go. I like these. I like these ideas. When non-lexical lifetimes. You guys know a lot more than I do. I admire that. Okay. Four hands again. Although I didn't do it right. I need to do this so you can see my two hands and then my other two hands at the same time. Lifetime annotations and struct definitions. So far, I've only defined structures that have to hold owned types. It's possible structs to hold references, but in that case, we would need to add lifetime annotation on every reference in the definition. Okay, so the life cycle of the structure is the same as the life cycle of that reference. Okay, that makes sense. We can do that. Because this is a reference, I'm guessing. And this just moves that reference into the I. The struct has one field part that holds a string slice, which is a reference. As with generic data types, we declare the name of the generic inside angle brackets after the name of the struct so we can use the lifetime parameter. This annotation means the instance of important excerpt can't outlive the reference it holds in its part field. And that makes sense. It creates an instance that holds a reference to the first sentence of the string owned by the variable novel. It'll work because they're all in the same life cycle scope. In addition, novel doesn't go out of scope, so it makes it valid. Okay. Lifetime elision. I like that name. That word, elision. However, in chapter 4, we had a function which is shown again, which compiled without lifetime annotations. Oh, yeah, I remember that. Where we returned a reference to that. So it just knew that since there's only one reference in and one reference out, that must be the same lifetime. This code wouldn't have compiled. This is what you guys were just saying. You're saying in the past, the compiler, you had to explicitly specify lifetimes more often. This is exactly what Key just said. Should give Key a point for saying that. At that time, function signature would have had to say, yeah, we have lifecycle A, it's all the same. After writing a lot of Rust code, the Rust team found that they were entering the same thing over and over again, and they're predictable, and the compiler could figure it out. Lifetime elision rules. There are cases that the compiler will consider, and if your code fits this case, you don't need to write them explicitly. They don't provide full inference. If Rust deterministically applies the rules, but there is still ambiguity as to what lifetime references have, the compiler won't guess what they should be. Instead of guessing, it'll give you an error that you can resolve it. That you can resolve by adding the annotations. Got it. Okay. Reading one chapter ahead. Oh, that could be. That might be the case. Hey there, Oblivioner. What uptime in the stream? It says below the video. It also says in stream. But my in-stream uptime is 30 seconds longer because I had to switch to a different uplink. Yeah, and that's true. Mobile doesn't show it in the new UI. Hey there, Pro Sam. How are you today? I need to drink more water. Like heart day, like less than 3 days old. Oh, you didn't need to do the heart. That's a rare where you actually do want to do less than 3 and it actually turned it into a heart. Lifetimes on function or method parameters are called input lifetimes. Lifetimes on return values are called output lifetimes. Makes sense. Compiler uses 3 rules to figure out what lifetime references have when they aren't explicit. The first rule applies to input. Second and third rules apply to output. If the compiler gets to the end of the 3 rules and it hasn't figured it out, it'll stop with an error. Fair enough. First rule of each parameter is that is a reference gets its own lifetime parameter. Okay, so by default it would be like A, B, C, D, and so on. Got it. Second rule is that there is exactly one input parameter of life. Second rule is if there is exactly one input lifetime parameter, that lifetime is assigned to all outputs. Oh, because we can have a tuple. I got it. Third rule is that if there are multiple input lifetime parameters, but one of them is self or mutable self because it's a method, the lifetime of self is assigned to all output lifetime parameters. Third rule makes methods much nicer to read and write, but fewer symbols are necessary. Yeah, because typically you would return something that has the same lifetime as the object. That makes sense. Like a getter would return a reference to something that is inside of the structure. Let's pretend we're the compiler. Let's figure out these rules. Yeah, so the first rule applies, right? There's only one reference, and so it's used on the output. Got it. Now let's look at another example. We have 2 arguments, so that's A, B, and this is second rule. So it's going to be an error, right? That's why we got an error, because it's ambiguous. There's no rule that tells us what lifetime is for the output. because we're not using self and we have more than one argument. I got it. Okay. Annotating lifetimes in method definitions. Yeah. Okay. Always need to be declared after the input keyword and then use after the struct's name because those lifetimes are part of the struct's type. Got it. The section seems to be generally greatly improved since the last time you read it. That's cool. I'm getting it, I think. Although it's getting kind of rough for me. The declaration after implement and its first use after the type name are required, but we're not required to annotate the lifetime of the reference to self because of the first elision rule. Yeah. First rule says it's the first input. Got it. Cool. And the third one applies here because of self. Right. There are two input lifetimes, so the rest applies the first and gives both self and answer their own lifetimes. Then because one of them is self, the return type gets the same. So that's A, B, A. That works. Because of the third rule, because there's a self. I got it. One special lifetime we need to discuss is static. So it's a special reserved word there. So we do that for literal string slices because they are static. So that's implied, right? That's implied. But that's if we were explicit, that's what it would be, right? Yeah, you might see suggestions to use static lifetime and error message before specifying and think about whether the reference you have actually lives the entire lifetime of your program or not. Okay. It's actually almost time for me to take a break. I think I'll take a break when I get to the end of this section. I've also been talking a lot more than I usually do. I can feel the stress on my voice. What am I thinking about building with it? Anything that goes into my current large project, which is the game I'm working on. So, once again, I've been building up this game, this custom game with custom game engine. The front end, you can see it's in the browser. I'm using JavaScript there. Maybe we could use Rust here. I don't know. The backend is in C++. Definitely, I think we could use Rust. Well, I'm not going to say I'm going to rewrite the whole game in Rust, but I could make new code in Rust for this game as an experiment to see if it performs better, if it's easier to develop, if I can write the tests better. Maybe I switch to using Rust instead of C++. But yeah, I don't have anything specific in mind. It's mostly like, let's learn Rust and see if it's applicable to my other projects, and this being my lifelong goal project, which is to make my own game. But, you know, I could also make a web server out of it, or a chatbot. I could rewrite a chatbot in Rust. The overlay that I'm planning to make for my stream could be in Rust. So it just becomes another tool to put on the tool belt. All right, so generic type parameters, type traits, and lifetime together. Ooh, we'll bring it all together. So here we have a lifetime. What is it called again? Lifetime specifier, lifetime reference, or just lifetime? Okay, we have a lifetime and we have a type, generic type parameter specifier. So we have to do that because otherwise they would assume different lifetimes, and we're returning the lifetime of either one. Got it. That makes sense. Okay, I got that. We don't need to do that. Hey, we covered a lot. Believe it or not, there's much more to learn on the topics in chapter 17 and 19. Can't wait. Generic lifetime parameter. That's this. So what's the name of this? Generic type parameter? Generic type parameter. They say it right here. Generic type parameters. Okay. I need to rest my voice for a few minutes. WASM support in Rust is pretty good, but integration of DOM and WASM isn't very good yet. Right. And hello, by the way, Aberrant Alpaca. How are you doing today? And I should also say hi to Peak 7117. Or 9117, sorry. I said your name wrong. It's Peak 9117. And Guitoro. Hello as well. Hold on, where was... Oh, there it is. Hello. Okay, I need to take a quick break to rest my voice. Also, my break timer is down to 11 minutes, so good time to take a break now. When I come back from my break, I guess we're moving on to the next chapter, which is automated testing. Something completely different than the rest of the book so far. This will be fun. I'm going to take a break and get back to automated testing in about 3 minutes. We're 3 minutes away from automated testing. Isn't that... It's like a cliffhanger. Woohoo! Someone said, woohoo, automated testing in 3 minutes. Okay, I'll be right back. Sorry, I'm a little late because I actually moved the mouse while I was on break, and it added 10 seconds to the break. Casper's enjoying a little bit of cream cheese on a butter knife right now. Okay. All right, we're gonna do automated testing. It's not a sharp knife; it's a butter knife. Yeah, licking off the cream cheese from someone who spread it on their bagel a little bit ago. He likes cream cheese, apparently. Yeah, he's not licking the sharp part. He's licking the other end. He's a smart cat. He wouldn't lick the sharp part of a knife. Okay. Do I need to read this, or is this just an intro to testing? Yeah, I think this is just an intro to testing, so we're moving on. How to write tests. Tests are Rust functions that verify that the non-test code is functioning in the expected manner. The bodies of test functions typically perform 3 actions: setup, run, assert. It's the 3 A's: arrange, act, assert. Probably already know everything. Well, we've been doing test-driven development in C++, like my TDD command says. So if it fits TDD, then we probably already know it, right? The test attribute, a few macros, and the should panic attribute. Okay, at its simplest, test in Rust is a function that's annotated with the test attribute. Attributes are metadata about pieces of Rust code. One example is the derive we used earlier. To change a function into a test, add the pound bracket test end bracket on the line before the fn. When you run your test with cargo test, it builds a test runner binary that runs the functions annotated with the test attribute and reports on whether each function passed or failed. Okay, that's cool. Let's see if I can just do it without reading anymore in the Fibonacci one, right? I don't actually need that one. So I have this Fibonacci function. What if we had a test for function test Fibonacci? I'm assuming it doesn't need any parameters, and I can just say Fibonacci 0 should... Okay, this is where I'm not sure how to do it. You'd need a mod test. Oh, right, really? Like how cargo already comes with these features? Yeah, it's kind of cool that comes with it. So already I don't know enough. When we make a new library project with cargo, a test module with a test function. Oh, right. This has to be in a library, not... What is it now? It is a binary. Right? Which one was our library then? That was the restaurant one. This one was a library. Not in the TOML. I forgot. How do we know it's a library? I can't remember. Oh, lib versus main. Yeah, you're right. Yeah, this has a lib, and this one has a main. So, to change it from a binary to a library, do I just rename it to lib and make it a mod? Hey there, SPJ. Also, I forgot to say hi to someone who chatted while I was on break. Xanax and BJ, can't wait till I get to object-oriented programming and inheritance chapter. We've done a little bit of that in the form of traits already. We've had a taste of object-oriented programming because traits are how you do interfaces, which are kind of key to object-oriented programming. But hello. There are options in cargo you can add to explicitly define libraries and binaries. Try writing assert, actual expected. Okay. I don't have to change it into a library? Okay. So I can just say assert macro. The actual will be 0, right? Assert equal. There we go. Yeah. Okay, so apparently all I need to do is just say go to Fibonacci and cargo test. Oh, look. That was sweet. I ran my first test in Rust. Yeah, he's even got a little button there. Interesting that it didn't work. Oh, it's assuming it's at the top level. Okay, well this is broken because apparently it only works if I have the cargo at the top level. But we can just use our own way of testing, cargo test. Yeah, I think it's just a limitation of the extension of VS Code that I use. It must be assuming that this package is at the top level of the workspace, but it's not. It's one level deep. Anyway, I'm just assuming that I can have multiples of these. Oops. Right? And this should still work. But if I change this to 2 or something, no, it won't work. Neat. I like it. And then I'm assuming that assert means it'll stop and not proceed. Because that's how it was in other test frameworks. So if I had like 2 failures, it's only going to catch the first one. Right? Yeah, it's only catching this first one and stopping. Does it have something like expect equal? Because that would be awesome. Nope. Oh well. Can't have everything. Yeah, if we didn't want it to panic, but we wanted to mark the test failed, there's probably a way to do that. I just haven't learned it yet. Let's learn it. Okay, they want me to make a whole library. That's okay. Okay, this is stuff that we got for free when we created a library before, right? Config test, I don't know what that means yet. Do they actually say what it means? Oh yeah, let's ignore the top 2 lines. Fine. Okay, so we already figured this out, right? Assert equal. Do multiple test functions. You think you have to have different test runners with additional libraries? Okay, so it's not as nice as I thought it would be. Because what I can do in C++ is I can make these asserts into expects. And then if this one fails, it'll still check that. And I'll do that to see, like, running the test once I can see all the failure points and not just one at a time. This one I have to, if this one fails, we don't know if this one would have passed or failed because it just stops here, right? That's not as nice. What are they telling me to do here? Oh, because we don't have any tests marked ignored, it says 0 ignored. We can control if they're run. I don't really care right now. In fact, why would I ever filter out or ignore a test? Don't we want to always run all our tests? The next part of the output, which starts with doc test adder. I don't get doc test adder. Hold on, what? Oh, right here. This is different, right? Oh, is it because we're not passing the test? So if I ran it again where it's passing now, it'll do that? No, it just didn't do it. Well, here it passed, but it didn't run it again. It didn't run the second... Okay, let me read about this. As a result of many documentation tests, we don't have any documentations yet, so but Rust can compile any code examples that appear. Yeah, it's an exe, not a library. Is that why? So exes don't have documentation? Okay, makes sense. Thank you, Ekton. They probably are going to tell me that at some point in here. I just haven't seen it yet. Thank you for the follow. Not more free pets for that kitty. That kitty's getting more pets than he deserves today. Yeah, it looks like it's a bin versus a lib thing. You can, but it's not on by default. Got it. Okay, yeah, that's self-explanatory. We can change the name of the test. We can add another test. We can use panic to make a test fail. Hydrate. I think it's time. It's time to hydrate. Cheers, Buff Siegel. Cargo doc test doc runs that. Okay, let me try it. No library targets found. Oops. I have a double shot of hydro. Thank you, Nightshade dude. As long as it's water, I will drink with you. I don't drink anything but water when I'm working these days. Yeah, well, there might be some other way. We just haven't figured it out yet. It would be kind of weird if they didn't let you have documentation for an executable. Because developers would want their own documentation, right? Anyway, yeah, I don't think we need to read this. I'm just going to skip right through this. Checking with assert. Okay, yeah. I don't need to read this. This is all, I already know this stuff. Okay, fine. I can read about this later. The minutia of how to run the test runner, that's fine. I don't need to know. Test threads, that's kind of cool. That's something Nui would appreciate. Okay. You can't build API docs or binaries? Huh. That's what my mentor would probably tell me at this point, that my code should all be in a lib anyway, and if I need binaries, it would be a wrapper binary, which is ultra thin, and all it does is invoke the library. Because that would mean your program can be embedded in a larger program, because it's a library. Right? Okay, what are they trying to tell me here? Showing function output, just using print. Oh, we won't see the print line output. I see. Who am I giving a point to, Mr. Halsey? Yep, we're gonna be hearing some banging for a while. Hold on. To me? I don't need points. Hold on a second. Sorry about that. And actually, I just noticed that that overlay kind of works funny with the beast cam enabled. I don't need points, Mr. Halsey. I have infinite channel points and all that stuff, so I don't need them. But thank you for the sentiment. Okay, when we see it, we don't see the print output, right? I never did fix that bug in point gifting, by the way. There was a command, it was gift. But don't try to gift to yourself because you'll lose all your points, remember? I haven't fixed that yet. This crate might be a good way to get that expect functionality. Okay, I'll look at that later. Thank you, Ecton Dev. I'm gonna put this in the notebook. All right. Nowhere do we see the I got the value for, which is one I want to see. If you want printed values, you just do show output. Okay, I don't really need to do that. This is just demonstrating how to use the runner. It has nothing to do with the language. Running a subset of tests by name. Yeah, I don't need to know this stuff. Yeah, well, I don't need to know this. I'm just going to skip right through this. Testing is neat. We can do it built into the cargo. Nice. Move on. Testing is a complex discipline. Different people use different terminology. Rust thinks about tests in terms of two main categories, unit tests and integration tests. Got it. Cool. I like it. It's in alignment with what I believe in. You'll put the unit tests in your source directory in each file with the code they're testing. I don't know about that. A module named tests in each file to contain the test functions and annotate module with config test. Okay, yeah, but why does it need to be in the same file? I mean, I guess I can see that it might be preferred. Someone 5209, you just lost a point, probably. Because I said not to do that. So now when I list your points, it's going to be 0 points. Wait a minute. Hold on. Yeah, you gifted 42 points to... What it is it's gift, target, number of points, and it capped the number of points to the number of points you had. So you just lost all of them. I'll have to give them back to you. There, you have your points back. Don't try gifting to... Yeah, let's just not use the gift command. It's kind of broken right now. Yeah. Yeah, don't do the gift command. It's kind of broken right now. Need to fix that. It needs to be more clear about how to use the command, and it shouldn't do weird things like gift points even though you typed in a number that was way too high. Did it actually gift to a user named 1? Yeah, I think so. Points 1. Yeah, so there is it even possible to have a Twitch name with a single character of 1? So if someone creates an account in Twitch with a name of 1, they'll have 24 or 42 points in the channel because that's where all those points were. Let's take them away. There, now they don't have any points, whoever they are. Well, that's how many he had. He had 42 points before. Smallest you've seen is 3. Limit. Okay, I've lost the thread of that conversation. Okay, yeah, it's a coincidence. Yep. All right. Test module and config test. It lets the Rust. It tells Rust to compile and run the test code only when you run cargo test, not when you do cargo build. Oh, okay. So the way I had done it here, the test I put in here is run even when we do. So that's included in the build. But if I want to do this right, I would do mod. I would do config test mod. What do they name it? And these. Thank you for the follow, by the way. I appreciate it. Mod tests. Okay. This is what they kind of want me to do, right? And that should still work. I should still be able to run the tests, or hold on. The module rules. It's not in that scope. They're gonna tell me how? Hey there, lazy guru. Look at that nice little wave emote you have. I can reply with my own little emote. Is that gonna tell me that? I have to use using super? Yep. Do they say why? Oh, but they explained that before. That's one case where you'd use the glob is in tests. Yeah. Using super glob. Am I doing that wrong? Use, not using is a C++ thing. Yeah, I'm too used to C++, as you can tell. Now it passes. I like that the testing is built in. That's really sweet. I don't have to install anything else. Yeah, you can test things that are internal because it's within, we're within the same scope of it. Okay, integration tests. I don't use integration tests much, but let's see what it says to have to say about it. Entirely external. They use your library in the same way any other code would, which means they can only call functions that are part of the public API. We create a test directory at the top level of the project work directory next to source, and knows to look for integration tests in this directory. We can then make as many test files as we want to in this directory, and Cargo will compile each of the tests as an individual crate. Okay. So we have an integration test. We have to do that to pull in the thing we're testing. We don't need to annotate it with config test because it's a dedicated test crate. I got it. Examples always work. Oh, is that why sometimes I see buttons for like actually running the tests? I don't know where I remember seeing that, but I've seen that in a few places where I can actually hit run and it would actually run the code. Yeah, here we go, like this. Run this code. I don't know where it put the output, but it... Oh, there. There's no output. You can actually run them in place. That's kind of cool. I guess if it had output, it would have put it in this little box here. Put it in that little box there. That's kind of cool. I should just try to do that too. Barely make any tests for your stuff. Above Siegel, come on, man. Unit testing, integration testing. It's what all the cool kids are doing. No more dirty CMake. I don't know about that. You gave me a point. Oh, thank you, SPJ. I don't need the points, though. I can gift myself a bajillion points. All right, test. Yeah. Each cargo is dedicated for testing. It actually names it with a unique identifier. That's interesting. The hash will be different. Okay. Oh. Yeah, so why do they have to have this hash number? Interesting. I don't know. Most of your stuff can't be testing for various reasons, and what can be tested just ends up getting a pull request with the full test covers by someone else. I see. Submodules and integration tests. Okay, this is getting a little bit thick. As you add more integration tests. See, I don't even do integration tests, so like this is beyond what I normally do. I usually just try to get everything working at the unit level. You might want to make more than one file in the test directory to help organize them. You might group them by functionality. Treating each integration test file as its own crate is useful to create separate scopes that are more like the way end users will be using it. However, this means files in the test directory don't share the same behavior as files in the source, right? Different behavior of files in the test directory is most noticeable when you have a set of helper functions you would like to be used, right? It won't be available, right? Yeah, a new section of the test output, even though this file doesn't contain any test functions, nor do we set it up anywhere. It's going to think that it's an integration test of some kind, right? Bless you. Someone walked by and sneezed. All right. To avoid having common appear in the test output, instead of creating tests, we create test common. Alternate naming convention that Rust also understands. Naming the file in this way tells Rust not to treat common module as an integration test file. Because of the word common, or because it's a subdirectory? Interesting. Files and subdirectories of the test directory don't get compiled as separate crates or have sections in the test. Okay, so it's just putting it into a subdirectory. Wiping hands off on cat. No. No, the cat just got extra pets. We train our kids not to sneeze into their hands. They sneeze into their elbows, inner elbow, whatever. Note that mod common declaration is the same as the module declaration we did before. Yeah, okay. Yes, I got it, I got it. Sneeze into your knees? That would be difficult, wouldn't it? I didn't say hi to someone. I apologize. The person I didn't say hi to is Vincent, who was playing around with the gift command. Hello. You cannot play around with the gift command without being subjected to the Raimu wave. Oh yeah, that's what he went and did next. He's actually working on something in the bathroom anyway. So, some removing some old tiles is going on there. Probably that's why he's sneezing, because he's kicking up dust. All right. Anyway. I don't think I need to read any more. I think we're cool with tests and integration tests and helper functions that go for tests. Okay, I was considering bypassing this chapter. We're done with tests. It's all built in and cool. This chapter, though, is not about testing anymore. I think it's some kind of challenge. It's a recap. I don't think I need a recap right now. I'm going to skip chapter 12 and move straight to iterators and closures. Let me update the current task. I don't think I've updated this in a while. Yeah, I forgot to say we were looking at... Just pretend for a while that it said testing. All right? Just pretend it said that for the last half an hour or so. And now we're skipping 12 and moving on to 13, which is iterators and closures. Sounds like fun. Yeah, don't kick dust. Dust always wins. Buckle up. Here we go. All right. Do I need to hydrate first? There we go. Functional programming is an influence on Rust. Includes using functions as values by passing them in arguments or returning them from other functions. We won't debate the issue of what functional programming is or isn't, but we'll instead discuss some features of Rust that's similar to features in many other languages referred to as functional. So we have closures, we have iterators, and performance of that. Spoiler, they're faster than you might think. Why are they giving us spoilers and not using the spoiler tag? All right. Closures, yes, they are anonymous functions that can capture their own environment. That's true in a lot of languages. So let's see what it looks like in Rust. Let's work on an example of a situation in which it's useful to store a closure to be executed later. Yeah, like an anonymous function. We work at a startup that's making an app to generate custom exercise workout plans. Backend is in Rust. Algorithm generates a workout plan, blah, blah, blah. What's important is that this calculation takes a few seconds. We want to call this algorithm only when we need to and only call it once, so we don't make the user wait more than necessary. So we have a simulated expensive calculation that'll print calculating slowly. Wait for 2 seconds and then return. Yeah, that counts, you know, pushing them through some roasted beans and drinking the results. That works. Although the beans might have made it so that you need to drink more afterwards, right? All right. I got a voicemail, and I want to see what it's about. Oh, okay. All right. It's a business call. I'll deal with it later. Okay, so thread sleep. That's actually remarkably similar to C++. In C++, it would be thread. It would be this thread sleep for standard chrono seconds 2. Okay. Yeah, the doggo barked at someone coming into the house. One of the kids entering the house from outside. The dogs is just sort of like a hairline trigger. The slightest thing that the dog doesn't expect causes a whole bunch of barking. Have I said that I'm a cat person, not a dog person? You can see the cat didn't bark. He's just kind of chilling there, kind of snoozing. All right, here's the algorithm. So this is the function. So they've put it in terms of a function, right? Yeah, it's a function. Okay, so far so good. What's the burrito doggo? He's a Havanese. You know, you have a knees, I have a knees, we all have a knees. It's a Havanese. Havanese. Cat person, yes, thank you. Thank you for redeeming those points. We will go pet the cat in honor of all people who are cat people. The cat waits for my demise, of course. And if he causes it, it's never direct. It has to be sneaky, so it can't be pinned on him. But, you know, that's their nature. He did get a double pet. Yep. Okay. It's just going into a lot of detail about the example. Refactoring using functions. We could restructure the workup program in many ways. Blah, blah, blah. Yeah, so we're getting the result frontmost, but it blocks it unnecessarily. No, it doesn't unnecessarily block twice, but now we're calling it and waiting in all cases, yeah. Okay, so here's what we were trying to get to. It only took a quarter of the way in for them to get to the point. Instead of calling it, we can define a closure and calculate it when necessary. So here's the closure. It's using vertical pipes. That's scary. Actually, it's not too different from C++, which uses brackets. So that's, I'm guessing that's the capture list. Start with a pair of vertical pipes inside which we specify the parameters to the closure. Yeah, so it's the capture list. Okay, so yeah, why is it chosen? It's similar to what it is in Smalltalk and Ruby. What, no nod to C++? Okay, if you guys hear some banging, it's because there's work being done by Remuspawn in the bathroom. Removing tiles today. I'm in the wrong section here. It's not just Adam who has to deal with banging. And where do I get that GTX plugin? Okay, so closures are like C++ lambda expressions. But instead of that for the capture list, we use vertical bars. Whack, whack, whack. Yeah, they're removing tile from the bathroom. Alright. Yeah, more than one parameter, it's a question mark. And I bet it's the same way, if you wanted a reference, you would say a reference, right? Yeah, I'm sorry, you guys have to hear the banging. Oh, it's the argument list, not the capture list? But it means the same thing, right? It's the things from the outside that you... Oh, no, you're right. It's not the capture. It's not the capture list. It's the parameter list. Except instead of that for parameter list, we use vertical bars. All right. I kind of wish that they had waited another hour to start banging on the walls. Hold on a second. Let me go ask and see if they can take a quick break. I requested that the banging be postponed for an hour. And before massive hole in wall. Yeah, I think they're going to be taking down a wall too. We're renovating the bathroom. Yeah. And the cat's getting free pets. Okay, so these are the parameters, not the capture list. I guess the capture list is implicit. After the parameters replace curly braces, these are optional. The closure is a single expression. Got it. To end the closure after curly braces needs a semicolon because it's a statement. The value returned from the last line will be the value returned from the closure. So that's the return statement. Got it. Plus no block camera. You want kitty. Yeah, sorry. Move, reference semantics, and Rust take care of the captures automatically. So it's kind of like in C++ where you do an implicit capture all, right? So, except instead of that for parameter list, we use that, and then capture is implicit. as in that, oops, that for C++, I think. Well, kind of like, I'm guessing. That is capturing everything by reference, so maybe it's more like star, I don't know. Let's just leave it that. Capture is implicit. There is no capture list. Hey, they're playing with scissors. How are you doing today? And Radon 90. Hello. And also Aura Driven. I'm really bad at noticing when people first come into chat. Where did Aura Driven... Oh, there it was. You waved to me about 10 minutes ago. Yeah. Got a couple minutes before your food is ready? Well, thanks for stopping by Playing with Scissors. I'm in chapter 13 of the Rust book. I'm learning Rust. This is day 3. Right now I'm going to be doing closures and iterators, and then smart pointers, and then threading, fearless concurrency, and probably that's going to be it for the day. I'll probably get through that and stop. If only I had a bot for what? Oh, for remembering? I do, it's just, it has a bug right now, in that the indicator's way on one side and I have to look like that to see it. I just need to update my stream helper. Okay. Okay, I get it. It's just an anonymous function with slightly different syntax. Thank you for the follow. I do appreciate it. This is still calling it twice, though. Oh, I think that's on purpose. Okay. Oh yeah, we're still calling the closure twice. Oh, the closure provides us with another solution. We'll talk about that in a bit. But first, let's talk about why there aren't type annotations. Yeah, why aren't there? Closures don't require you to annotate the types of the parameters or the return value like a function. Type annotations are required on functions because they're part of an explicit interface exposed to your users. Defining this interface rigidly is important for ensuring that everyone agrees on what the types are. But closures aren't used in an exposed interface. They're stored in variables and used without naming them and exposing them to users of our library. Okay. You totally derailed the stream to ask me to explain this voice meter setup? Sure. Really quick. My voice meter setup is, I have... Well, they give you 3 slots for inputs, so I really only needed one for gaming headset and the one on the right for this guy. The middle one, I just popped in the webcam. Anyway, so each of these columns is a microphone, and then these columns are the virtual inputs. So one of them is all of the audio I want to be heard on stream, so I named it on stream, and the other one is everything like Firefox that I don't want people to hear on stream, so that's off stream. So those are both virtual inputs. And the A's up here are the hardware output devices. So I think it's my headset, and then my speakers, and then because I have a third one, I put my ultra wide monitor on. I never use A3. So when I have so for what I hear, it's what's on here. So right now I'm hearing on and off stream on both the headset and the speakers. So if I didn't want the speakers to play, I just do that. So now I'm like, I have to put on my headset to hear sound. And then the microphone selection is the B's. So which microphone I want to be heard on stream is whichever B1 I click here. So if I switch that to this one, you'd only hear me if I speak through the headset mic. And then the B2 is for the Windows sounds. So I have B2 coming in here. It's a little bit confusing because you'll see A1 in different contexts here, and they sometimes mean the same thing. I get confused myself, and I tried to rename things to have things make more sense. So like this A1 headset speakers TV matches these A1s, And yeah, they sort of match here too, but it's a little confusing anyway. I hope this makes sense. These are my audio outputs are the A's, and the audio inputs are these 3 columns. And you connect them like a switchboard, and then you have your virtual inputs and your virtual outputs. So, yeah. To make it make sense in Windows, I took like the A and B, whatever, and made that part of the names of the devices, and also made the names of the devices have things like on-stream, off-stream, so I could keep track of them. But Voicemeeter Banana gives you 2 virtual inputs and 2 virtual outputs. And the virtual outputs, see, this is where I get input and output mixed. Virtual output means it's a playback device, right? So that would be these are the outputs. Right? And then the inputs are, see, I think I'm getting them confused already. I think that's right. These are the, no, I'm totally confused. Don't listen to me. I need to get unconfused. How am I going to get unconfused? It gets confusing because you have hardware input output and you have virtual input output. These buttons here are all connecting the inputs and the outputs together. These are connecting physical hardware inputs to physical hardware outputs. These ones here are connecting virtual inputs to physical outputs. No, the other way around. Physical inputs to virtual outputs, and then, yeah. So each of these quadrants it's a combination of hardware versus virtual input versus output. It's been incredibly hard for you. Yeah, hard for me too. You can tell I can't even explain it right to you. Just click stuff and it worked. Just think of it as it's a big switchboard, and it's mixing both physical and virtual inputs and outputs all together. So you'll have all 4 combos: hardware to hardware, hardware to virtual, virtual to hardware, and virtual to virtual. And I believe it's this top left quadrant is hardware to hardware, and the bottom right quadrant here is virtual to virtual, and then the top right is virtual to hardware, and the bottom left is hardware to virtual. Yeah, I think I got it. So this B1 here means the hardware microphone is going to virtual output B1. So that means I'm using this microphone and feeding it into a virtual audio device. And then that equates to what I tell OBS. So in OBS, I have a B1 mic. And so if I switch B1 onto here, OBS would be picking up this microphone instead of this one. So if you didn't hear me at all when I turned that off, right? If I turn this one on instead, now you'll hear me through this thing. Now you'll hear me through this thing instead. See how that works? So this is routing my microphone to a virtual audio device. So the opposite of that would be where do all my virtual inputs go to my hardware devices? So what am I listening to are all these switchboards. And then I hardly ever use hardware to hardware. That would be if I want my microphone to come directly out of my speakers, right? So if I did that, now I can hear myself out of my own speakers, right? Now, these are virtual to virtual, and this is what I use to say what I let you guys hear. If I turn this one off, you won't hear any of my Windows audio. If I turn these both on, then you hear both Firefox and everything else. So there's no difference right now because I'm not actually playing anything from Windows. Your immersion is ruined. It gets even more complicated here because of all the tools you can record and play back on different buses, and there's different levels. That's as much as I'm going to say. Hopefully that helps you out playing with scissors. See ya, JT. Sorry, I didn't mean to scare people away by doing that aside. But Rust main point is really about good coding and memory management practices. Yep. Okay, let me get back to closures and... Is this chapter just about closures? No, it was about closures and iterators, right? Closures and iterators. No problem playing with scissors. Maybe we can highlight that to keep it for later, because maybe when I get confused next, I can listen to my own highlight. Right, they don't need to have type annotations because they're private. The compiler is already able to infer the types. Making programmers annotate the types would be annoying and largely redundant because the compiler already enforces other rigor to make it unnecessary. Right. As with variables, we can add type annotations if we want to increase the explicitness and clarify the cost of being more verbose and strict than necessary. So we could say, hey, yeah, this had better be a uint32, and we'd better return a uint32. So that will basically take this and say, make sure it's a uint32, otherwise it's a problem. Will I listen to my own highlight on A1 or B2? In the case of voice meter, it would be A1 up here. Unless I played it on Firefox, in which it would be off-stream A1. Depends on the app that I use to play it back. See how that works? Anyway. The syntax of closures looks more similar to the syntax of functions. Yeah. Except for that they're not using parentheses here. I guess because it would be complicated syntactically to do it that way. Because in JavaScript, you'd use parentheses, right? That looks like an arrow function, except for JavaScript would use parentheses there. Right. If you use type annotations, it looks like a function. Yeah, and they're showing the breakdown of comparing the two. Good. Cool. Closure definitions will have one concrete type inferred for each parameter and their return value. Closure isn't very useful for the purposes of example, but here it is. This is just returning it, the parameter. So if S is closing on the return value of that, then it's just going to return that same number, yeah. Oh, wait, no, hold on. It's using the same closure, right, but it can't infer it, so you get an error. Okay, yeah, I don't know where my mind went there, but that's okay. Instructions on clear sounds coming out of motherboard. Oh, I see what you're saying. Okay. Storing closures using generic parameters and the function traits. Ooh. Pipe makes to you no sense in the context. It's just they couldn't use parentheses, right? If you think about it, like if you know JavaScript, it would be parenthesis x, close parenthesis, arrow x. It's just an arrow function, and they couldn't use parentheses, so pipe is just an alternate character they use. It is sort of a wacky delimiter when you think about it. Like, couldn't they have used angle brackets instead? Any other kind of brackets? All right. Ruby uses pipes, so maybe that's why they got their inspiration from Ruby. They're like, it works for Ruby, let's use it here too. Save the result of the expensive closure in a variable for use, and use the variable in each place we need to the result instead of calling the closure again. However, this method could result in a lot of repeated code. We can create a struct that will hold the closure and the resulting value of the closure. The struct will execute the closure only if we need to. It'll cache the result, so we don't have to... Right, this is lazy evaluation. I got that. Still enjoying Rust checking. We're getting into the more difficult concepts like closures, which are, in a sense, anonymous functions that hold some state in them, right? And we haven't gotten to how it holds state yet, but how it closes on things, but this is an anonymous function. It just has some kind of wacky syntax with the pipes that I'm told are look like Ruby. I don't know Ruby, though. The FN traits are provided by the standard library. All closures implement at least one of the traits. FN, FN mutable, or FN once. Okay. We add types to the... What are we talking about FN traits? I lost. I missed that. Oh. This is what I missed. I think. Okay. We add types to the if and trait bound to represent the types of the parameters and return values that closures must have to match this trait bound. For example, our closure has a parameter type un32, returns un32, so the trait bound we specify as function u32 returns u32. Here's a definition of it. Oh, I see. A closure is represented by a special kind of trait. Yes? Yeah, so it's the type of the closure. Okay. I'm having to read this a couple times to get this part. So that's the closure stored inside of the struct catcher. Got it. Oh. I will hydrate and I will answer that question, Nui. So what is a union in C++? It's the same as a union in C. You can think, if you know Ruby, a union is just an enum with a where without you a union in C++ is an enum in Ruby without the actual values of the enum. It's just all the attached data that you normally have in a Ruby enum is what a union is in C and C++. So in a sense, the Ruby enum is an evolved form of a union. So if you have in C++ or C a union X, and then you have like int A float B, you would normally have to associate that with like a discriminator, like X type, like an enum, right? Enum X type, A or B, right? So in Ruby, in Rust, you would just say enum X, and you'd have A I32, and you'd have B F32. Does that make sense? So if that in Rust is an enum with attached data for two different values, it's the same thing as having a union along with a discriminator. I guess that would be, and you have to store them separately. Something like that. Or I guess you can do it with this. You can make the enum anonymous and do that. Should have the dog on A2 so we don't hear it. Yeah, I'd have to isolate the sound somehow. I have not dropped any frames at all today. So it might be just you, or it could be Twitch. Hey there, Tua Bud. And also, hey there, Lazy Greed. We have both a Lazy Greed and a Lazy Guru today. And Mudikins. Hello. So you guys tell me if I got that right. If this is in C, whoops. If I understand correctly, in either C or C++, that's the rough equivalent to that in Rust. The dog didn't come with sound driver settings. Nope. Yeah, I'm working on that refund. Let me save this actually, and then I can, why is it wanting to put it there? I don't know, but this should go into Rust. And this is enum versus union. Yeah, enums and unions put together. But when you think about it, a union isn't really useful on its own because you don't know which field of the union. Essentially what this is, it's a structure that has space for the larger of these two values, and they share the same address. So if you assign something to the A field of X, you're overriding the same memory that B is going to take up. So you can only really use one or the other of these two fields, because they share the same address. Conceptually, it's the same as Rust, where the data storage for this x is shared between this integer and this float, and which one you use depends on something called a discriminator, which is built into Rust, which is the actual enum values. And in classical C, C++, you have the discriminator be somewhere else other than the union, and the two go together. I guess that would be, more correctly, it would be that, right? So x has to have an associated discriminator to know which one you're using. And the discriminator also doubles as the same, you know, the same enumeration. Can you rewatch the 2 episodes before? Of course you can. Right now they're in my VODs, and they will be uploaded to YouTube on the weekend. Wait, Rust made unions enums? Yeah, exactly, Jacquemus. That's what Rust did. Rust combined the concepts of union and enum together. If you don't need a union, then you just drop the attached data, and then that is exactly equal to that now. See how that works? So if you have data associated with an enum in Rust, it's like having a union attached to your enum, which I think is pretty dang cool. All right, going back to the book. Will you have an application for Rust, or I'm just interested in it right now. If I like it a lot, I might start using it in my other work. Many functional languages did it before Rust. Okay. I don't mean to steal their thunder, but from my perspective, this is the first language I've run into that works this way. Oh, it's unsafe code? Well, why would you use it? I just use the enum. It looks pretty cool. All right. So this is a special trait provided by the Rust standard library to represent a closure, and the way it's used. Is this syntax specific to that trait, or is this something you can do with all traits? I don't know. Anyway, it looks like a function type. That's how I'm going to treat it. Rust is a thing you would use if you had to do native code. Scala for managed code, Rust for native code. Okay. That is magic syntax, unfortunately. So I should probably write this down. Let me put it in my notebook. Closures are like C++ library expressions, except rather than the type being a construction of standard function of a template, i.e., standard function. Actually, it would be EG, right? I always get IE and EG mixed up. Function, let's say RT, just so I can use consistent naming. A special trait is used, e.g. FN T arrow R. So standard function RT is the same as function T arrow R, if I got that right. Yeah, they both start with E. Okay, yeah. I can never get those straight playing with scissors. Enjoy your food, by the way. You think in the enum comparison it got something wrong in the C++ part? Enum, create enum object. Yeah, I actually did mean to make it an object, not a type. Yeah, I actually wanted it to be an object. But I might have screwed up the Rust part. I meant it to be an object, not a type. But I can fix it later. I've hashed it to death. But thank you, Nui, for pointing that out. I like being pointed out when I make mistakes. Okay, so then the trait bounds on T specify that it's a closure by using the FN trait. Any closure you want to store must have one. All right, must have that parameter, must return that. Got it. Functions can implement all 3 of the function traits too. If what we want to do doesn't require capturing a value, we can use a function rather than a closure where we need something that implements a function trait. I don't quite understand what that's saying. Yeah, yeah, it's hard to get 2 things exactly equivalent, right? Let me try to read this again, see if I get it. Functions can implement all three of the function traits too. So when they say all three, what do they mean? I'm not sure what they mean by all three of the fn traits. Do they mean fn mutable, or fn once? That must be what they mean, right? If what we want to do doesn't require capturing a value from the environment, we can use a function rather than a closure. So functions must have a different type syntax then. Yeah, okay, cool. Before we execute the closure, value will be done, yeah. Yeah, okay, I see how this is going. It's going to check to see, it's going to do a match. Self-value, exactly. So if it has a value, just return. Otherwise, it's going to call the closure. Oh, that's interesting. That reminds me of how we call functions through a pointer in C, only without the star. And that's probably because of the same operator precedence rules. That you have to, we want to evaluate this first without trying to bind this to that word. Yep, and then store it because it's a mutable self. I get it. All right, I get that part. Call the value if it's some or if it's none. Shows how we can use this catcher. Right, so we just call it. And value is where we do the match. Got it. Instead of saving the closure in a variable directly, we save a new instance of catcher that holds the closure. Where did that happen? Oh, right here. Oh, no, right here. There's where it was. Got it. Traits are interfaces, yeah. Exactly. So, this fn is a kind of interface that's defined by the standard library, and it's the interface that closures have to implement. And there are three types of them, apparently. They talked about fn, but there's also fn mute and fn once, and I'm guessing that this means the closure can be changed, and this one is the closure can only be used once. I'm just guessing. We save a new instance of it that holds the closure. Then, okay, yeah, that's because we're defining the closure and putting it into the structure so that it can cache the result. Got it. All right, I got it. I got it. Only once and when needed. Got it. Limitations on it. Caching values is generally useful behavior that we might want in order to use other parts of our code with different closures. However, there are two problems with that current implementation. It assumes we'll always get the same value, yeah. So there's no way to dirty the cache, to clear the cache. Yeah, so this will ignore the value 2, right? You get 1, 1 probably. Yeah, okay, that's what I thought. The first time we call it with 1, it saved it as 1, and then no matter what we call it, it returns 1. Try modifying it to hold a hash map. The keys of the hash map will be the arg values that are passed in. The values of the hash map will be the result of calling the closure on that key. What? Oh, that's to expand the space of results to be... that's kind of like what React does. It's memoizing. You're memoizing the results based off of the input state. So if the key is different, you'll recalculate it. Yes. Memoize. They're saying to memoize it is one way to do it. You don't understand memoization? It's the concept that if you know your output depends on a constrained set of inputs, then once you've calculated one output based off of one set of inputs, if you get the same set of inputs again, you know you don't have to recalculate it. You just look up what the output is for that. But if any one of the inputs changes, then you know the output could be different and you have to recalculate it. And once you've recalculated it, then again, you store the output somewhere so that if you get that same pattern of inputs again, you know what the output is without recalculating it. So the memoization process is forming a mapping between the inputs and the outputs, so that if you see the same thing again, you don't have to recalculate it. So it's used whenever it's expensive to get an output from a set of inputs. They do that in the React hooks, where using in the like the state hook, or is it the effect hook? Yeah, in the effect hook, it knows it doesn't need to call the effect function every time. It only needs to call it if a certain set of inputs changed. Time to speed up the fib program. The Fibonacci? Yeah. So we can memoize Fibonacci, right? We can have a hash map where if we've already calculated f of n, then we can just get it and not recalculate it again. Second problem is that it only accepts closures that take one parameter. We might want to cache the results of the closures that take a string slice and return size values, for example. To fix this issue, try introducing more generic parameters. Okay. I think this is saying if you want to explore fixing it, then you can try that. Anyway, capturing the environment with closure. This is important, right? That's one of the things that closures are really powerful for, is capturing their environment. They capture their environment. Oh, they do it implicitly too, right? Yeah, you can see that here. We only pass in z, so where did it get x? The answer is that it stole it from its parent. Yes, that's true, my friends. Children steal from their parents, especially if they're closures. It's not one of the parameters. It's allowed to use it. So I guess it's not stealing, it's borrowing. That's what my kids say too. I'm not stealing your car, I'm just borrowing it. All right, we can't do it with functions. It won't work because it's going to say that, oh, I didn't even know you could do that. That's cool. So you can make a function inside of another function, but you can't borrow state that's not a parameter, because that's only something a closure can do. Yeah, closure form instead. It's really nice to see the error messages say, you can't do that, try this instead. It uses memory to store values for use in the closure body. The use of memory is overhead that we don't want to pay in more common cases where we want to execute code that doesn't capture its environment, because functions are never allowed to capture. Defining functions will never incur the overhead, right? So in other words, functions in Rust are pure. You might hear this word pure. It means that there is no overhead, there's no state, there's no baggage. Closures have baggage, state, and overhead, right? They capture in three ways. They can take ownership, they can borrow mutably, and they can borrow immutably. Got it. And they are encoded in the three fn traits. So fn once consumes the variables it captures from the enclosing scope. So it must take ownership of these variables and move them into the closure when it's defined. The once part of the name reflects the fact that the closure can't take ownership of the same variables more than once. Good to know. But well, what I mean by pure is that they're pure with respect to the outer environment. Sure, they can accept a mutable reference, but they're not allowed to directly mutate variables declared and outside their own scope. What's the similarity between 2020 and 2022? 2022 is 2022. Mr. Balrog. Hello, how are you doing today? Okay, fn mute can change the environment because it mutably borrows values. Okay, and fn borrows values. So that's why the spirit of Rust is that default is immutable. So the default one without any name decoration means immutable. If you need to mutate, you use the mute. And if you need to consume, you use once. Okay, I get it. When you create a closure, it infers which trait to use based on how the closure uses the values. All closures implement once because they can be called at least once. Closures that don't move the captured values also implement mute. And closures that don't need mutable values also implement fn. Oh, I see. So a closure kind of gets these traits depending on what it actually does. And that the more traits you have, the more flexible that closure can be used in, right? I get it. So it might be that you make a closure that can only be called once. It might be that you make a closure that not only could be called once, but it can also be used anywhere that accepts mutation. And it could be used in all three, because not only can you call it once, and you can call it where you're allowed to mutate, but you can call it when you're not allowed to mutate. I think I got it. Rust functions can interact with the I/O system. They can read static variables and even mutate them, but that's unsafe. Yeah, let's stay within the realm of safe. I think there's always a desire to stay safe, right? If you want to force the closure to take ownership of the values used from the environment, you can use the move keyword before the parameter list. This technique is mostly useful when passing a closure to a new thread to move the data to its own. Yeah, so that's what we do with standard thread in C++. We move its state in so that it is consumed. So this is kind of like standard move then. It's basically saying, not only do we want you to use X, we want you to own X. I mean a Z. Not only do we want you to... no, I said it right the first time. Not only do we want you to use X, we want you to own X. And Z is still passed as a parameter. So we can't use X because it's now the property of equal to X, the closure. Got it. It does not implement the copy trait because it was moved due to the closure moving it. I like these error messages. They're nice. Cool. I got it. Okay, so I should write this down. I'm going to forget this. That's another difference between closures and lambda expressions. So, captures, actually put it under the other bullet point. Would make more sense, right? There is no capture. Let's not. Captures by default, not copy. Does they say what the default is? Let's say captures by default do not take ownership. You can add the move keyword in front of the parameter list. I'm bad at typing right now. Parameter list to change this to have the capture take ownership. All right, I got it. I don't know about the exact C++ equivalent of that. In C++, you can capture by value and by reference. By value kind of maps the copy trait. By reference, it's not exactly taking ownership, is it? It's sharing ownership, which you're not allowed to do in Rust. All right, so we receive this error, of course, because we tried to use X. Yeah, okay, getting back into this. Most of the time when specifying one of the fn trait bounds, you can start with fn, and the compiler will tell you if you need that based on what it needs. Oh yeah, that makes sense. So fn is the most strict and rigorous, and fn mute is relaxing a little bit, and fn once is relaxing even more. I get it. To illustrate where closures can capture the environment as a useful function parameters, let's move on to our next topic, iterators. What a segue that was. The iterator pattern allows you to perform some task on a sequence of items in turn. It's responsible for iterating. Oh yeah, we know that. In Rust, they're lazy. It means they have no effect until you call methods that consume the iterator to use it up. For example, this one makes an iterator, but it doesn't actually iterate yet, right? Need 1 year more to understand closures? I think I got it well enough, but I could be wrong. So an interface may require a closure that implements fn once. You can provide a closure that's just fn, because fn encompasses fn once. Yeah, that makes sense. Fn is more strict than fn once. So if you say you support fn once, then it can take an fn because that means it's even more strict and won't violate the rules of fn once because they're looser. And fn once is the loosest for when you say what you require, and fn is the strictest. Yeah, and it goes, yeah, it's hard for me to explain it, but I think I got it in my head. Don't ask me to write it out in English, though. That's maybe a warning sign that I don't really understand what I'm saying. Okay, I'm out of water. I could go to take a quick break. How much more do I have until I get to... I thought I would get to concurrency today, but I'm really slow. I think I might have to end it at the end of chapter 13 and do concurrency and smart pointers tomorrow. Yeah, because I promised my family that they could bang on the wall after an hour, and I don't want to keep them waiting too long. Let me finish this chapter and we'll call it. Do you already do the IO project? No, I kind of skipped it because it was like a recap. They even said so. Not flying through as much, yeah. Yeah, I skipped the IO chapter because they actually said so in the first sentence. I think is a recap. I didn't feel like I needed a recap on live on stream. I might do this off stream just to make sure that I really understand everything so far. You can draw it with circles. What encompasses what? Yeah. But from two different perspectives. The closure itself is one end of it, and then the thing that takes the closure is the other end, and they're reciprocals, right? So one is requirements, and the other one is acceptance. So yeah, a diagram would be useful there, I think. Back to here. Or is that where I was? Hold on. I don't remember where I was. I think this was where I was, right? No, I was right here. No, I was right. I was on this one. Got it. Seems too complicated to be adopted more widely as a C++ replacement, but I like the rigor. We went over this at the very beginning. Where did I put it? Why Rust? No, pros and cons. Rigorous and strict. I think of it as a pro. It was told to me as it's a con. As like, this is how it was told to me, that here are the pros and cons of Rust. It's fast and it's safe, but the drawback is it's rigorous and strict. My reaction to that immediately was, to me, rigorous and strict is a pro. Hey, welcome back, A Squared. Were you gone for a while? You were gone for a couple hours. You're gone for an hour and a half. I am probably going to wrap up the stream soon. I'm going to try to finish the chapter on iterators and closures. Why do bees have sticky hair? Because they use honeycombs. Complicated parts of C++ are all the parts that you learn to make your C++ code sound anyways. Just formalize a certain approach. Yeah, that... I agree with EctinDiv. I'm going to give a point to that because, like, the ways at which I use threads and constrain myself and how I use closure or lambdas and smart pointers are all formally adopted in the syntax and rigor of Rust. So it kind of just codifies what I'm already having to do to keep things safe. So it's in alignment with what I want. Strict structure makes you do good practice. Yeah. And if you're already used to doing good practice, it's probably easier to use. Okay, so we're creating an iterator. We're not yet using it. We just hold on to it for now. It's like an iterator in C++, right? And then here we're actually using it. And it's syntactically the expression that in expects is something that is an iterator. They're probably going to say it has to have an iterator trait, aren't they? In languages that don't have iterators provided in the standard libraries, you likely write this with a index and loop through. Yep. Iterator trait in the next method. I guessed it. So if something has the iterator trait, it can probably be used in the for in loop, right? And then next mutates the self and returns you. It's exactly the same as a C++ plus operator. Or the next in Lua operates exactly the same way. Got it. So it's the same as what I already know, just with a different syntax. Oh, there's a type. That's new.
Most of the enforced principles are just the good way of doing it. Yeah, I would agree with that. Slowly grew to write code in a more functional and unit-testable manner. Yeah. It matches a lot of your thoughts. I think that's a good realization to make, that this is a language that's attempting to codify good code design, or to define, to restrict programs to fit good code design. And if it matches what you're already doing, then that's a good sign, right? Okay, what's this new syntax mean? Defining an associated type with the trait. We'll get to that in chapter 19. Okay, for now, all we need to know is that the code says implementing the iterator trait requires that you also define an item type. Okay, and that this item type is used in the return type of the next method. Oh, so it's kind of like a template. This is a template argument, right? Or is that how we, in C++, where you have a template base class? Enumerators are weird and look like try, while, move, next, dispose, make sure that they always get cleaned up. Oh, okay. Yeah, it makes sense, A squared. We can call on it directly if we want, and they're going to do it here. Hold on, what's that? What does @1 mean? Why do we have to say and1 here? That's weird to me. Why that? You get a reference to a number back? Oh, okay. And it's very strict about that. Interesting. Check the signature. I will. Yeah, you get an option, but option... I'd have to look at the definition of option. So you're saying a definition of option is sum has a reference to the item type, right? You can't mix and match. You have to compare references against references. Right, so sum, the associated data for sum is a reference, you're saying, right? Or is it defined here and I just didn't see it closely enough? No, it's just option. There's no reference there. So this item must be a reference type. You have to look at the vector iterator. Okay, I got it. I mean, it makes sense. You're not going to transfer or borrow something with the option. You can't borrow it. You're not going to move it out just by iterating it. Yeah, option and yeah, that's what I surmised. You don't need to make it iterable because the loop took ownership of the iterator and made it mutable behind the scenes. Got it. Right, the iter function did it. And that's what for loop did for us. So for loop is calling iter for us, right? No. Oh, okay. So it is doing something behind the scenes. The for loop is doing something behind the scenes. It takes ownership and makes it mutable behind the scenes. Okay, that's good to know. Let me write that down because I'm going to forget that. Okay, iterators. For loop takes ownership and makes mutable the iterator you give it. The for loop behind the scenes takes ownership and makes mutable the iterator you give it. Got it. Are immutable references to the values in the vector. Iter method produces an iterator for immutable references. If we want to create an iterator that takes ownership, we would call into iterator instead of iterator. Huh. That one makes more sense to me. This one's new to me. Returns owned values. So like moving things out of the vector. This one is just a non-const iterator. So let me write this down. iter is roughly equivalent to a const iterator in C++. Iter mut is roughly equivalent to a non-const iterator in C++. There's also into iter, which takes ownership of the values iterated. Into prefix is supposed to be used in contexts where self is moved into the method consumed. So I should really think of into to mean or imply consume. Got it. All right, we can do that. Consume the iterator. Oh, this is consuming the iterator. Right, okay, I got it. Some of them call the next, which is why you're required to implement the next method. Methods that call next are called consuming adapters because calling them uses up the iterator. One example is the sum method. The other one was the for loop, right? And it makes sense. So you can't use the iterator after you've summed it. Beast is on the move. Yep, he did a little rotation. Did a 1080? He's got to move around until he's got that, finds just the right spot. I should probably clean that spot too. There's a lot of little bits of carpet and things that he's pulled out with his claws. We aren't allowed to use it. It's like I just said, you can't use it after sum because it takes ownership. Got it. Methods that produce other iterators. Iterator adapters allow you to change them. So like maybe reverse or map. No, that would be consuming. Reverse. You can chain them to perform complex actions in a readable way. They're all lazy. You have to call one to get results through them all. One example is map. Takes a closure to call on each item. So it's the same as the JavaScript map. In fact, it looks exactly the same, only without the parentheses and the arrow here. And that will produce another iterator, right? Yeah, so it's not I was going to say, you're not doing anything with it, so yeah, it doesn't do anything, so it's not consumed. Yeah, we would use the collect. This method consumes the iterator and collects the resulting values into a collection data type. Sounds good to me. So here we're going to collect it into a vector. So we take the original vector, make an iterator out of it, and then map it through a closure and collect it to get another vector. I think I got it. It is just like JS, isn't it? Only in JS, you didn't need to do collect. Well, actually, I guess you do need to do a form of collect. In JavaScript, you'd have to put that in a bracket with a ... to expand it back to an array, right? Atomic nibble. I am out of water. I'm out. Here, I'll drink some virtual water. Or I can take a quick break to get water. Hold on. Super fast break to get water. I'm back with the water. Cheers, Atomic Nibble. How are you today? You could have me pet the cat, because the cat is available to be pet. Because map takes a closure, we can specify any operation we want. That's cool. We already know that from JavaScript. Using closures that capture their environment. No free pet? No, you got to pay for it with channel points, but I'm sure someone else will redeem some points, unless we've run out for today. Oh, there you go. 715209 has your back. We gotta go pet the kitty. How do you like these cleverly designed micro breaks that we have built into the stream? It's like petting the cat is like a little micro break. Okay, we're going to get through this. I need to finish soon because I did promise my family that they will be allowed to bang on the walls as soon as my stream is done. And I give them a rough timeline of around now. Okay, we can demonstrate a common use of closures as a captured environment using the filter iterator adapter. It takes a closure which takes each item from an iterator and returns a Boolean. If the closure returns true, the value will be included in the iterator produced by filter. If the closure returns... Oh, I think I see how this is going. So, actually, maybe I don't. I don't understand this, I guess. Oh, no, I do. It's the closure needs some outside information other than the input to set the filter criteria. So filter doesn't take the criteria separately. It just takes a closure, and the closure is responsible for that. So it has to capture shoe size to compare it to the thing that's being passed in. I got it. Most popular Rust SQLite crate is called Rusculite. I like how that sounds. Neat. Let me give you a point for that, because we're going to be using SQLite, right? There's already a crate for it. That's awesome. Although that means I can't do it myself, which makes me a little bit sad, but that's okay. I'll get over it. Thank you, A squared. Wrong window. This one. I want to check out SQLX too. Okay. Will do. Ecton dev. It's interesting because it offers compile time SQL syntax. Ooh, I like that. Because if you watch me work on the SQLite stuff, you know how many times I had test failure due to a badly prepared statement. I like that. Oh, what happened to my... Hold on a second. Something, part of my wrist pad fell off. There we go. Fixed it. Don't reinvent SQLite again. Okay, I won't. We'll use the crate next time if we do it in Rust. Yeah, so I think I get it. We capture the shoe size, and it's immutable by default because we didn't do move. Okay. Takes ownership of the vector of shoes and the shoe size and a shoe size as parameters. Wait a minute, what? Oh, right, that thing. Yes. Okay, got it. We create an iterator that takes ownership of the vector we call filter to adapt that iterator into a new iterator that only returns elements for which closure returns true. Got it. Creating our own iterators with the iterator trait. All we need to do is do the next, right? Yeah, the only method you're required to implement is next. Once you've done that, you have an iterator. Neat. So you can make anything iterable by implementing the iterator trait on the thing that is going to be your iterator. So they have a counter here, and you can make a new one, and they're probably going to say, well, let's make an iterator for our counter. Yep. Here's our iterator for counter. Oh, I see. Counter is an iterator. So it's built into the counter. And then next is going to return the count unless we get to 5, I guess. You're also going to put a picture about some neat things with the cargo toml syntax in Discord to provide multiple ways to specify things. Oh, thank you very much, A squared. Yeah, if you guys want to talk about anything post-stream, or if you have more information, or you just want to chat and ask questions, I have this Discord there. You're all welcome to join that. All right. This is just explaining what I already know, right? Yeah. It has to mutate the self. I got it. Using our counters iterator next method, so we can just use it with directly. And because it doesn't take a reference, it is just a value. We don't have to use the reference. I got that part, yes. And then using other traits. Ooh, there's more than the next. Hold on, what? We implemented the iterator trait by defining next method. So we can now use iterators trait method default implementations because they all use next. Oh, I see. I see. Yeah. So zip. Wait a minute. Wait, what? If for some reason we wanted to take the values produced by an instance of counter, pair them with values produced by another counter, after skipping the first value, multiply each pair together, keeping only the results are divisible by 3, and add all results together, we could do so. Oh, because, I get it, because zip, map, skip, and sum are all default, what are they called? Methods of a trait? They are all iterator trait methods that have defaults, and they all use next. Got it. Okay. Good to know. I think I'm done. So this is just going back to the recap and trying to apply the knowledge of iterators to improve on the project that I never did. Okay, cool. I need to what's the right word? I need to fulfill the promise I made to my family that they can go bang on the wall after an hour, after they've given me an hour of peace so I can stream. So I'm going to cut the stream short. Well, actually, I'm not cutting it short. It's past 4 hours, right? We're going to just find right now as a nice stopping point and come back to... I'm probably going to skip 13.3. Do we want to do 13.4? That's just comparing performance. That's just more like... Yeah, I think we won't need to do that one. So I think when I come back tomorrow, I'm going to, I might even skip 14. I think we're skipping 14 because I'm not going to do crate.io stuff. I think we're going to start tomorrow's stream with talking about smart pointers and then do concurrency. This is going to be fun. So we'll be doing threading tomorrow in Rust. Can't wait to do that. I have to really resist the urge to look this stuff up beforehand. Yeah, we're going to start on chapter 15 tomorrow. And actually, we might be able to get through it all, right? We might have a total understanding of Rust. Yeah, so if I can get through the rest of the chapters that I want to tomorrow, I still want to go figure out how to use this with C++. That's really important to me. So I've accomplished, I know how to break it up into pieces with modules and crates and packages. I know how to do interfaces, that's traits. We know about the life cycle of objects, that's borrowing and lifetime annotations, and that's how we share objects too. So life cycle and sharing is kind of handled the same way. What's left is how we do asynchronous tasks, and that's going to be covered by concurrency in chapter 16. You almost know enough to start building stuff. Yeah. So I need to know how to do concurrency, and I need to know how to integrate it with pre-existing code in other languages. So I'm going to try to accomplish these tomorrow. Give some examples of the thing coding for looking at whenever. All right, cool. Okay, cool. Thank you very much, A Squared. I am going to leave this stuff that I have highlighted here for tomorrow. I'm going to go find someone to raid right now, and I'm going to go eat my lunch. I hope you guys all had an awesome day today. Oh, I got a notification from Twitch. I no longer have to wait for manual emote reviews. Your emotes will now be available immediately upon upload. Wow. You guys see that? This happened 2 hours ago, apparently. I don't know if I did something or if all creators or affiliates get this now. I no longer have to wait for manual emote reviews. They'll now be available immediately upon upload. That's cool. So if we can just come up with the emotes and have them instantly available after we upload. Oh no! CM Griffin, you're raiding me and I'm about to raid someone else. It's a good thing that I didn't try to raid you at the same time. I gotta go eat lunch, Chris. I'm sorry. I'm sorry. Please forgive me. I gotta go. Well, so Chris, who would you like me? Who was your second pick? You have a work meeting? Okay, help me rate someone else. We got to rate someone else. And we'll just pretend Chris rated them directly. Wait like 1 minute for the ads to roll so all the viewers get sent on the rate too. Yeah, it'll take me that long to figure it out anyway. Bald Bearded Builder was second. Okay, we're going to rate Bald Bearded Builder. I'm looking for Bald Build. There it is. Okay. Clicking on his link. So welcome everybody from CM Griffing's channel. My name's Raimu, and usually I'm working on my own multiplayer game, my own game engine. And but the last few days I've been learning Rust, and I started today on chapter 9 of the Rust book, and I made it all the way up to chapter 15 is where we're going to start tomorrow. So we handled a bunch of things today. We did closures, we did iterators, we did automated testing, we did lifetimes, we did error handling. We had a fun time. So if you're into learning Rust, then my VODs will be available, and I'll be coming back tomorrow to do smart pointers and concurrency, which is really fun stuff. But for now, I gotta go. I'm sorry we have to do the raid train thing, and we're gonna raid Bald Bearded Builder. Whoops, and I hit the wrong key there. Hold on. Professional streamer here. All right, gonna raid Bald Bearded Builder. Hopefully you guys have fun on his stream. Let me hit this raid button now, so that we go there. Here we go. So thank you again for the raid, Mr. Sir. Sorry I have to pass the buck. But you guys, please enjoy Bald Bearded Builder's channel. I'll be back tomorrow for more Rust learning. Thank you very much, and see you 715-209 and A Squared and CM Griffing. Thank you very much. Look, my break timer says I need to take a break, so perfect timing. Thank you very much. See you later. Bye.